Student joins on Anathan. Okay, hi. Can you guys hear me? Can you give me a yes or no? No, no, I wasn't speaking. I'm sorry. Now, yes. Okay, we'll get started. Sorry for the delay. Okay, my voice is breaking. Is my voice breaking for others? What about now? Is it clear? Is there any audio issue? Okay, no. Okay, it's clear. Okay, it's breaking for some of you. Okay, I'm sorry, really sorry. It's your internet. I'm sorry. Okay, if the voice is breaking. Okay, really sorry about that. What about others? Can you give me yes or no? Is my voice breaking? Yes or no? Is my voice breaking? No. Okay. So it's fine. Okay, cool. So we'll continue. I think we spoke about the eye yesterday. Yeah, sure, Shashank. I'll give it in the end. Remind me later. Okay. Few things I had to discuss with you. That is, one is about the browser itself. We were doing some problems last time, if you remember, with ray optics. I think, did I explain about this? Did I explain about how the eye works? How does it focus? Yes, there was a Schoology discussion that was started. I'll let you guys know about it towards the end, not now. Okay. Now, this is something I've not done. Okay. This is something that's not done. Listen carefully. This is very, very important. This is critical for solving some of the very important problems out there. Okay. So listen up. Let's say I keep an object at 0. So there is an issue. Whenever, let's say there's an object and my eye wants to focus. This is my retina, let's say. This blocker that you see is my retina. And it's trying to focus the rays. It has a focal length of 78 now. Okay. Now the question is, initially, initially the focus is 100, that's fine. If the object is far, it can do something and adjust the focus. Okay. Like, for example, what can I say? If the blocker is placed somewhere here, let's just say it's placed here, it can form an image. But if the object comes closer, the image goes behind much more. Okay, if the object comes closer, there's a, okay, wait, sorry. One second, sorry. Yeah, I'll have to place this at 78. 1 second, yes. Now, if the object is very close, what happens is the image is formed on the screen. You can see that. Is that clear? Can you see that? Give me yes or no on that. Yeah, okay. So now you can see the image is formed. That should be clear. Now what happens as the object goes far away is that the image is formed before the retina. Okay, before the retina. It's not formed there. It's formed a little bit before. Now the question is, what can the eye do? What does the eye do when it wants to focus this? What does the lens? What does it do to the lens? to focus the image again? What should it do? Yeah, it should increase the focal length, right? Now, in order to increase the focal length, what should happen to the lens? Should it become thicker or thinner? It should become thinner. Now, how do you make a lens thinner? Tell me. If you know the eye structure that you saw earlier, how do you make the lens thinner? Yeah, by elongating it. But the problem is the muscles, are they designed to elongate? The question is, are they, see, are these, okay, can they squeeze? Can these muscles squeeze the lens? They can squeeze and push on the lens and make it thicker. But how to make them thinner? How to make the lens thinner? Okay, the muscles have to relax, right? And the lens comes back into its position. But the problem is, no, if the muscles cannot relax sufficiently, the lens cannot increase the focal length significantly. Like it will fail. Like for example, I'll give an example. It can try. Let's say it can go on trying. Let's say it can probably go on increasing the focal length to, let's say, 88. It's almost there, but it's not sufficient. Let's say it can extend a maximum to a value of 82. Let's say. Okay, you can't contract more, and these people cannot see objects which are further. Okay, wait, I'll push it much more further. So right now you see you require an optical lens. If the object is really far away, you require something like wait, let's say we keep it here. One second. I think this is a mistake from my side. Let's say it can expand to a maximum of this. Let's say it can maximum, the eye can focus, I can increase to 82 maximum, let's say. Okay, let's say the eye can increase the focal length to a maximum of 82. Now what happens if the object goes further away? What happens here? Where is the image formed? Much more closer, right, before the retina. So the question is, can I increase further? See, I'll have to increase further to improve this thing. What is it? To make sure the eye falls on the lens. But let's say 82 is the maximum it can do. It can't do better than that. Okay. Now the question is, we have to solve the problem. What do we do? How can we solve the problem so that this image is formed in the retina, even though eye has extended to its maximum possible focal length? Usually in a normal eye, the focal length can be can be adjusted. What is your solution? What do you think is a solution to make sure this image is formed again on the retina? You can increase the focal length. What should I do? Yeah, people say you have to wear spectacles. What does a spectacle do? Okay, some of you are saying use a lens. Which lens? Yeah, Nidhi, you're right. Yes, Sumant, you're right. You guys are suggesting okay, Varun is also suggesting the same thing. You have to use a concave lens. Okay, so what I'm going to do is I'm going to take a concave lens and I'm going to place it in front. Now observe what happens when I place it. Okay, before that, I want you to remember, if I place the object at 200, the image is formed perfectly. If the object is before 200, the image is formed perfectly. Hope you guys got that. Okay, now I take the object really. There was an issue. I'm really sorry. Can you guys hear me now? I don't know. Something weird happened. Okay. Hope you can still see the screen now. Is that fine? Screen is back. Yeah, should be back. The screen is back now. Okay. So if you look at it now, the image, the question is, if it's at 200, oh, sorry. If it's at 200, if the object is at 200, it can focus on the screen. Now the problem is, if the object is really far, image is not formed. So you say you get a concave lens, which is very close to the eye. Okay, what the concave lens does is it diverges the rays a little bit. Can you see that? It bends the rays a little bit more away. Is that clear? Can you see it? Can you give me a yes or no on that? And then that makes it focus again. It's like the combination of two lenses can adjust the focal length accordingly. The power of this lens is positive. Okay, the power of this lens is positive. We require a lens of lesser power to focus the image, to increase the focal length. Hope you agree with that. Do you guys agree? Can you give me yes or no? Do you agree that in order to increase the focal length, I have to decrease the power of this lens, but I can't decrease it. Okay. Now, if I were to add one more lens which has a negative power, this has a negative power, right? Diverging lens has a negative power. If I get it sufficiently close enough, you know what happens? The powers get added up. What is the lens with focal length 0? That's crazy. Power is infinity. So you can't discuss that easily. Okay. Power is infinity. Okay. Now listen up carefully. Okay. Okay, I'm sorry again. There was some another technical issue. I don't know. It's my internet. It's unstable. I'm really sorry. Okay. Yeah, I know you couldn't hear anything. There was some issue. I'm really sorry. Uh, I guess we'll be back 1 second with the presentation. This is annoying. Okay, did you guys get this part? Why a focal? Why would you say a concave lens is used? The rays diverge a little bit more. Okay. Okay, I'll come to that plane thing. Okay. Yeah, I'm going to turn off the video so that you guys can hear better. What about now? Can you? Did you guys get this? Can you give me a yes or no on this? Did you guys get it? Why this focal length does a better job? Okay. Now, do you guys understand much more deeply? Okay, here's a question. Here's what I'm saying. When you get this new, initially the image is not formed, and people who have what you say myopia, they cannot what you say elongate the lens even more. So the image is formed before the screen. Okay, before the screen, before the retina. So what they end up doing is, now this object is very far. Earlier, if the object is at 200 meters, they can see them. But if the object goes further away, this is the maximum they can do. This is the best they can do. They can't elongate the lens even more. So to help them, what we do is we introduce another lens, a concave lens, which spreads the rays again further outward. Okay. Now here's your clue. Why does this lens happen to work? Why does concave lens happen to work in this case? That's the question I have. The concave lens ends up focusing back on this thing, but why does the concave lens do it? Sorry, concave lens do it. What happens when you increase the focal length? When you increase the focal length, the rays go further and further away. No, it doesn't. No, it doesn't. This image is a real one. Vivek, by the way, this image formed is a real one here. Can you see it? This image formed in the retina is still a real one. Okay. Okay. Many of you are saying, see, if you look at it, what would have happened if the object was here? If the object was, okay, this is your hint. This is your hint. Listen up. If the object was at 2, okay. If the object was at 200, the rays would be coming at some angle and they would hit the screen. Hope you agree with that. They would come in at certain angle and that would lead it to hit the screen. But if the object goes further away, the angle decreases. Hope you can see that the angle goes on decreasing. The angle becomes much more steeper. Okay. But when I introduce the lens, what happens? The angle again increases. Yeah, it diverges the rays even further. But there is something deeper going on. Now listen to this carefully. I don't know. Okay, I'm going to let you guys figure it out. Why does the convex lens, I know, I understand the diverging part, but how does the concave lens achieve this image coming on the screen again? How does it do it? Your hint lies in a problem that you did yesterday. Your hint lies in the problem that you did yesterday. I gave you a problem deliberately based on this. You have to find the focal length of something. Do you remember that? You have to find the focal length of a lens and stuff like that. If you remember. Yes. That's your clue. That is your clue. Okay. This is how your spectacles actually work. It's much deeper than rays diverging and all that stuff. It's much more beautiful, what your spectacles do. Okay. How many of you here have myopia, by the way? How many of you have myopia here? Okay, a second report. Sorry if the voice is breaking for some of you. Okay, cool. Yeah, its power is negative and that of the concave lens is positive. I get that. I get that. So you end up having the combination of power. So you understand the power of the convex lens is positive, like let's say plus 1 or something like that. Whereas the concave lens will have a power lesser, like a little bit lesser. So when you add both of them, you get a power which is still positive, but smaller, slightly smaller, which means you get a longer focal length. Okay. Okay. The question is simple. Why does this concave lens end up focusing the rays on the screen? Why does the introduction of convex lens? Yes, Nidhi got it. Okay, Nidhi got it. Nidhi figured it out. Yes, yes, yes. Okay, Nidhi, I have a simple question for you based on your answer. What do you mean with the actual object? Actual object? Yeah, most of you say it increases the angle of the rays. I get it, but there's much deeper. Nidhi, you answered it right, but I have a question. What does it mean for the rays to go beyond? Yes, yes. Nidhi figured it out. Okay, Nidhi knows this. Power combined. Yes, you can say the powers combined and all this stuff. But the beautiful thing is this image. What does it tell you? This is your next clue. Nidhi has figured it out, but others I want you guys to think. What's happening? That's your clue. The chain that I made is your clue there. Is anybody thinking? Okay, first question I have is where is this? Where is this? Yes. Can you see a virtual image at 200? Most of you can see a virtual image at 200. Yes. So this virtual image is formed by which lens? Can anyone tell me? Which lens forms? Yes, which lens forms the virtual image? The concave lens, the first lens. So the first lens brings this object from 0 and places it at 200. And you know the person can see up till 200, right? The person can see up till 200. Yes, person can see up till 200. So the genius thing this lens does is it brings the object from that far and places it here. Okay, so that's the crazy part of how your lenses work, your concave lens or myopic lenses work. Okay, they bring the image from further away and places it perfectly at which your furthest point is of your eye. Okay, people with myopia vision have a furthest point. Everything blurs after that. Oh, that's the question you had asked. I didn't get that. I'm really sorry. It's like mirror in cars. Mirrors do something a little bit different, so I don't want to get into that. Mirrors don't place the object near. Okay, so if you look at your yesterday's problem, and I think I discussed this. If you remember this question, yeah, this one. If you look at it, I asked you. There's an image. This is the maximum the eye can focus. Yeah. Now the question is, what will happen if the image comes from much further? Right. That's the question. Okay. Uh, So the world we see is virtual. No, the world you see is not virtual. Okay, I want to clarify that. Nidhi, 1 second. I'll go back to this viewpoint. Okay, so if this ray wasn't there, the rays were coming directly from this point and hitting your eye. So all that matters is, okay, Nidhi, if you're asking the question, am I seeing a virtual image or a real image? You are seeing the real image itself. The real image is formed on your retina. Okay, at the end of the day, it's a virtual image, a real image itself that's formed at the retina. But the rays come from, what do you say, a virtual point. So technically, it becomes a question: can I call it a virtual image or a real image? I would. Okay, this is a more philosophical question. Are you seeing this, or are you seeing this? Are you seeing what's at 200, or are you seeing what's at 600 here? That's the question. What is it that your eye sees? Yeah, exactly. That's a good question that led to the confusion. Yeah. Now, I would say you're seeing what's at 200. Okay, you are seeing what's at 200. Okay, now the reason I'm saying this is your eye is a separate entity. Okay, look at this. This is a very important point I'm trying to make. Now listen up. Let's say this lens wasn't there. Okay, I'll remove the second lens. Okay, uh, if you were to have the eye independent, let's say you place the object anywhere, the eye would adjust and make sure the image falls on this thing. Okay, and a rays would fall here. So if you go anywhere, let's say you place the object anywhere, the eye would completely adjust. For a normal person, the eye will adjust no matter what. Okay, even if the rays are very close, the eye will be like, I'll adjust the focal length such that actually it adjusts the focal length. Okay, I'm adjusting the screen, but the point is you can't move the retina back and forth, so we end up adjusting the focal length. But my point is, no matter where the rays are coming from, the eye adjusts. Okay, so it's like you don't have to care about the eye where the image is formed or anything like that. You just have to care where the rays are coming from. The eye will adjust no matter what. Your eyes are designed to adjust. Okay, so if you ask me the question, what are we seeing? We are seeing the rays coming from this point. So what we see the whole time is a real image of things, like rays come and hit us, and from that point we see the rays from that point. But this is important. When you introduce a lens like this, a second lens, yes, Nidhi, you're right. You're seeing a virtual image formed at 200. You are seeing a virtual image. So people who wear lenses, for most part, they're seeing a virtual image, not a real image. A image from further away, really far, is brought and placed at your furthest point, which you can see. Okay. Okay, somebody asked if a person, that means if a person has very high, Muralidhar says, if a person has very high power, tries to feel the object where he's. Oh, okay. You're saying the person won't be able to, what do you say? The object won't be where the person touches it. Oh, that's a good question. Wait. Muralidhar is a very good question. If the person has a very high power, let's say, okay, and he has severe myopia, which means he cannot see anything beyond 400. Okay, anything beyond 400. He asks the question, if he's trying to see an object at 400, will that object be seen at, what do you say, will he confuse it being at 400? If the object is far away, will he confuse it for being at 400? Okay, now it's a very good question. I'll clarify that later. That's a very good question, because it has something to do with the, what do you say, the not just the accommodation, it's got to do with microscopes. Okay, yeah, good question. I know, even you have that question. Good. Look, here's the thing. Here's something I didn't tell you guys about. Okay, this is something I have to add. Before that, 1 second. Rays come a virtual point for all or only for those with. No. If you're myopic, if you're wearing a concave lens, what you're seeing is a virtual image. Okay, a virtual image is created from this thing. What happens if the ray comes from further away? I'll come to that. I'm going to come to that. That's the point I have to make. One more thing I have to add. But wouldn't that virtual image again become a virtual image from the concave lens? I didn't get that. The image formed is virtual because of the concave lens. Concave lens is forming that image. It's not, what do you say? There's no second concave lens. There's only one concave lens. Yes. Somebody added, do the eyes change the focal length first, and does it feel the light rays are not focused completely? Or does it feel that the light rays are focused completely? No, the thing is, your image gets blurry. So if you look at your hand right now, and if you keep it against a background, like a very, what do you say, you will see that if you move your focus, you can focus on what's behind, let's say some window, and at the same time you can focus on, you have to face your hand against some window or something, bright light or bright object which is further away. You will see, if you look at it, you can change your focus from that to this, so the object gets blurry, and depending on the blurriness, it adjusts this thing, what is it, eyes adjust. So that's what I have to say, Muralidhar. Okay, so as he goes further away, the virtual image readjusts. Okay, I understand the virtual image keeps changing. Okay, if you go further and further away, virtual image readjusts. If I take it much more further away, the virtual image is formed, let's say, much more further away, not at 200. If it is here, it's probably formed at 200 or something like that. You can see that. But if you go beyond it, there's a problem. Okay, there seems to be a problem. I've actually moved the whole setup. Sorry. I think our earlier point was around 200, right? Yes, there it was. Sorry about that. Yes, there. So this was a setup we had. So if I move the object much more further, you can see the image is formed beyond this thing, beyond. Hope you guys got that. Okay, this is a question I think that was asked by Keaton also and many others. If I take the object further away, the image is formed even further. So what to do about that? Okay, but then again, while coming to the lens from 200, then oh, by the way, the rays from 200 don't come in contact with this lens. These are virtual rays. These are extended rays. These are extended rays. These are not the rays. The rays are coming in and going outward like this. Look at these rows. These rays do not exist. Okay. By the way, rays are not leaving from 200. Rays seem to leave from 200 here. They seem to come from there. So this lens thinks the object is placed at 200 thanks to this lens. If this lens wasn't there, the object is placed where it is. But this lens tricks the second lens, our eye lens, into thinking the object is there. Okay. Yeah. Now, what's this phenomenon called? Selective focus. I do not know. I think it's called selective focus. That makes more sense. General process is called accommodation. The ability of the eye to do that is called accommodation. But the phenomenon, I don't know. I'm not sure. Okay. And the person cannot understand where the object is placed. I'll come to that. I'll clarify that. Okay. Okay. The image on the retina is a real image or a virtual image. That's a real image because the rays are meeting at that point. That's the most important. The way to distinguish something is a real or a virtual image is to ask yourself whether the rays meet at a point. Do they meet at that point? Yeah. Now, what is the lens? Well, I'll speak about hypometria later. Now, here's the important thing. Listen to this. I'll take this further. I'm going to take it much more further. And I'm going to place the lens there. And this person still cannot see beyond what you say. Wait a second. The lens is there, 650. And if it's between somewhere around 400, it can be focused. Okay, it can focus, kind of. If it's at 200. 1 second, I'm sorry, what is this? Yes. Now, this person can focus if the, wait. This person can focus if the rays are somewhere at 500 or something like this, at 450. Okay. Now, when I introduce this lens, if the object goes further away, let's say at 200, you need a concave lens like this to focus. Okay, focus the rays. You require a concave lens of larger power, something like, let's say, we need to keep the object at 450, right? We replace the object at 450 here. So I need a larger focus. Something like, let's say, 450. Yes, there you go. Places at 450. Yes, it's formed now. Okay. It was off, not or. I didn't get that. Okay. Anyways, but you get the point, right? The image is formed at 450. The person can see completely. Now, what happens if the object person goes really further? That's the question most of you are asking. What happens if the object goes much further? This lens cannot adjust. Okay. Now, you must understand one very important detail. When people design lenses, they don't design lenses to position this 200 object, this object which is at 200. Okay. People do not design this lens to adjust such that people can see what's at 200. So what's at 200 can be seen by anyone. The question is what about what's everything that's further? Okay. Now I'll reduce this brightness so that you will understand what I'm getting at. I'm going to introduce a parallel beam of rays. Where are these rays coming from? Where are these rays coming from? Can you tell me? They're coming from an object. They're coming from some object. Where is that object? Yeah, that object is at infinity. Now, if this lens wasn't there, let's say, this is the maximum shift the person can make. Hope you agree with that. Let's say if the object is at infinity, the person clearly can't see, because you agree with that, right? The person clearly can't see. If the object is here, let's say this green one here, if you look at this green object, the person can at least focus them, okay? A person can at least focus them on the screen. I hope you understand. If the object is at least at 200 or something like that, the person can still focus them. Look at it. The person can still focus them here if the object is at 200. Now the question is, if the object is at infinity, the person still can't focus it. It's worse, much worse. So what people do is, people don't design it for this. People do not design the concave lens for this source. People design the lens for the object at infinity. So people introduce this new focal length, concave lens, and adjust that one for the object at infinity. Okay. So what happens is, if you look at edges of focal length sufficiently, you can see even the object at infinity is formed on the retina now. Now you get any other object. Let's say you get any other object. Uh, what happens when you get another object which is at 200 now? Can anyone tell me? Let's say you're wearing the lens. What happens? This lens is designed for you to see every object at infinity also. Okay. Whatever is at infinity also should be able, you should be able to see now, because the object can focus something at infinity, and that is placed at one second. That is placed at 200 where the person's this thing was. The rays are coming from infinity, by the way, and that object is placed at 200 where the person can see them. Now, let's say if I were to switch off this parallel rays, and let's say I introduce some object which is placed here, okay, which is placed at 200. Now you see the image is formed behind the retina. Is this a problem for a person wearing the lens? Yes, Satvik is right. This isn't a problem. The person can still adjust the lens, right? The person had a problem with increasing the focal length, but person doesn't have a problem with decreasing the focal length. So he can decrease the focal length and bring the what do you say, closer, image closer. Let's say he adjusts to, let's say 73 or something like that. The image is formed. So do you get it? The lens is designed for object at infinity. So even if the object is at infinity, brings and places the object at around 200. It places it at 200. But if the object comes much closer also, it can still focus because the person can adjust the eyes for that. So those of you who worn spectacles right now for a long time and with high power, your eyes are very much used to the lens, okay? Very much used to the concave lens. They have been adjusted to adjust their focal length for that, okay? That it becomes really hard without the spectacles if you have very high power. And whoever has high power can experience this the most. I personally have, I think, around 2 right now, so it's fine. But I have astigmatism, worse astigmatism than focal myopia. Yeah, I get that, Amrita. Okay. So hope you guys got it. Did you guys get this? The lens is designed to place object at infinity at your near point, at your furthest point. Sorry, furthest point. Is this clear? Can you give me yes or no? So even if the object closer comes in, the eye can focus because it's not a problem for it. The eye's only problem is it cannot focus anything that's further than a particular value. Yes, the spectacles in our eyes are not perfectly convex lenses nor concave, because they use a variant of that called concave or convex lenses, variants of that, which have some advantages which I do not know of. Okay, you can look them up online or discuss them, but there are some advantages. Bifocals are something else. Bifocals are those where there are 2 types of lenses. People have 2 problems now. People with bifocals, they cannot see objects which are nearby. At the same time, they cannot see objects which are further away. Okay. So as people get older, usually they end up with this problem. They cannot see even things closer. At the same time, they cannot see objects which are further. So you require 2 types of lens on the same glass. They require a glass which can focus, which can focus on rays which are further away. So to see distant objects, that's a concave lens. They also require a convex lens to focus everything that's nearby. So to do both of them, they require both the lenses on the same glass. So that's why you have 2, you have an arc-like structure for close viewing. If you're reading something, they use that. Okay, they won't cancel each other because they're not on the same part of the glass. They're on the bottom part of the glass. The concave lens is on the bottom part of the glass for reading, which are objects which are closer in bifocals. What is the object is formed so much beyond the retina that the eye lens cannot be squeezed further. Yeah, that's the myopic condition. You can't see objects which are nearby. That's the thing I mentioned to you yesterday also, right? I told you your eye as a near point. If you get your finger very close, the image gets blurry. Did I discuss that? Why the image gets blurry? If you get your no, that's hypermetropia. I get it, metropia. But the thing is, even for a normal person, he cannot get his eyes very close. The finger very close and focus on it. Okay, that will be still blurry. But then people with hypermetropia, they have a problem that they cannot focus even objects which if the object is even further beyond the nearest point of the eye. So that leads to a lot of stress on the eye. That's why your eyes start hurting for some of them. Okay, so to focus, they have to strain the eyes a lot. to focus on to read something because they have hypermetropia. Okay, so it hurts the eyes a lot. So that's why they get headaches and many other things. Okay, so that is for long-sightedness. I was discussing just now long-sightedness. Short-sightedness, the muscles have to stretch. Muscles have to stretch. Why is it difficult to focus on nearby things on a bright background? Oh, I don't know that. I'm not sure. At least I'm not experienced, so I don't know the answer to that. We got to think. Why is it difficult to focus on nearby things on a bright background? Maybe the eyes are not so great. You know, there is a, okay, when you move your finger around, when you move your finger or your hand around, your object can track it. You can your eyes can keep tracking your fingers continuously. Hope you have seen that. Okay, there is something called a shoreline illusion. Guys, I'll tell you that 1 second. Please read up about it. I think something called the shoreline illusion or something like that. It's really weird. I think that might be able to tell you how does the okay, I think I remember it. So keep look. Okay, you need to look yourself in the mirror once. Okay, for this. And most of you have a lens, you have a camera, webcam there, right? So you should be able to see your eyes for this. Okay, this you have to be very careful for this. Move your hand like this across continuously and keep tracking it. Keep focusing on the hand continuously as you move it from left to right. Hand from left to right as it moves. Start from the left and slowly move it to the right. Now, if possible, in the webcam, if you look at it, if you record that video and look at it in the webcam, you will see your eye doesn't move continuously. Your eye will move like step by step, little bit will move, then it'll move again, then it will move again. Okay, I think it's called the shoreline illusion or something like that. You need to look it up. It has something to do with what Muralidhar is saying. I think it has some connection because of the way your brain processes the information. Okay, quick summary on spectacles. So why does this spectacle get introduced? So for myopia, specifically for myopia, we end up diverging the rays a little bit more. So that the person, let's say if the person has a problem that they can't see beyond 400, let's say they can't see beyond 400. If the object is at 400, they can see it. Okay, they can see it properly because they can bulge the lens even more and increase the focal length. But the problem for them is they cannot decrease the focal length more. They cannot decrease the focal length. So in order to decrease the focal length, they need the help of a concave lens. The thing the concave lens does is it takes any object at infinity, let's say anything that's emitting light from infinity, like this beam of rays which are coming parallelly. What it does is it places objects at infinity at the near point of the lens, at the near point of the person, that is somewhere here at 200. So infinity is placed somewhere here. Okay, and then that is projected onto the retina. This lens takes it. So in a way, yeah, that's how people end up seeing things. Now I need to clarify one more thing, and this is a detail I need to add. Some of you asked me, don't people see objects nearby then? Okay, don't people see objects at infinity very close then? Okay, won't the world get completely distorted? Yeah. Now I asked you a question long back, like really, really long back to some of you. When you place a lens before your eyes, okay, before your eyes, and when you look through the magnifying lens, the images appear inverted if the object is really far away. Do you remember that? Do you remember that bit? Yes. The answer lies there. Why does the image appear inverted? Okay, why does the image appear inverted? You guys have seen it. The image appears inverted. Why is it inverted? That is a question. I think Muralidhar has answered it kind of sometime in the past. I think so. I don't know whether it was this question, but yeah. Yeah, I'm giving the quick summary. That's a quick summary. I told you, right? The spectacles. Yeah, how can we see it? That's what I was mentioning right now. The what do you say? The rays from infinity are placed at the near what do you say? The furthest point of the eye. This is the furthest point the person can see. The rays from infinity are placed at that point by this concave lens. And the second lens takes that as an image, and focuses it on the retina. Okay, does that clarify for you? Whoever asked me for a quick summary of it, I was just trying to do that. Or do you have a doubt? If you have a doubt, you can ask. The rays, yeah, okay, the light rays intersect, and after intersecting, they get inverted. Oh, by the way, one more thing I need to clarify: is the image formed inverted? look at this. If I were to send a ray, let's say like this from the side or anything like, okay, one second, I'll delete this beam so that you can see it now clearly. Raise brightness. Yeah. Now, if you look at it, initially the image is formed there and everything is fine. But is this image inverted? Is the image formed on the retina inverted? Yeah, it's always inverted. Do not forget that. The image formed in the retina is always inverted. Okay. So your head, basically your brain, flips the image later. Yeah, your brain is used to it, so it flips the image. It knows that. Uh, I don't know what the world would look like if you had a pair of lenses that flip. I don't know if you guys have tried this. I've done this stupid thing. Okay, in my childhood, I used to take a mirror, place it very on the ground. I would place the mirror on the ground and go very close to the mirror and see through it. That's a stupid thing to do. I don't know how many of you have done it. Just let me know if you have done it. Okay. It's a very stupid thing, but look at the world from that point of view. Just try it today. Okay. Just try it today. Yeah. Some of you have. Take a mirror, place it on the ground, and then go very close to the mirror and see through it. Okay. It feels like the wall is the ceiling or something like that. Sorry, ceiling is the floor. And yeah, some of you have tried it. Yes. Okay. Yeah, most of you have done it. Okay, cool. So yeah. So my point is simple here. It's just that your brain has been eventually gotten used to the fact that, image is not inverted. Okay. Yeah. Hang upside down. Yeah. Somebody is suggesting hang upside down. Yeah, that's something you've done in childhood. I don't know, from a swing or something like that. I think I'm going to do it today evening. Just going to keep the lens on this thing, and people are going to make fun of me in the family, but yeah, it'll be fun. Okay. Anyways, going ahead, I think, yeah, the image is also diminished. How does the brain reckon the height? Yeah. Now, the brain is very good at this. Okay. It has gotten used to it. That's the simplest explanation I can give. Okay. The brain has gotten used to it. So it adjusts for the height. First of all, I have a question, Muralidhar. Here's a simple question. Can you look at a pole and estimate its height? Can you look at a pole and estimate its height? You can estimate, but can you tell exactly? Okay, does it matter if that lens, what do you say, if that image was magnified or shrunk, or if something had happened, would it have done anything to you? Would it have changed anything for you? Okay, your image, what is formed in the eye, your hand would touch the pole where, look, if you have a pole like that, and if you're trying to touch the top of the pole and the bottom of the pole, when you touch the pole, even if the image is distorted by the eye, let's say a little bit, slightly, your brain would somehow compensate for that and tell you that, okay, you're touching the pole at the top itself, irrespective of what. Because the image of the hand, image of the pole, touching it, that wherever it happens inside the retina, it's happening at some point, right? You know that you're touching the pole. So even if the image is inverted, or if the scales are not right, let's say the scales are not right, let's say the retina height is different of the image on the backside of the retina, the brain knows to adjust for it, and it has adjusted for a very long time, so it knows it. Why does the image at infinity appear inverted? I didn't get that part. It's not inverted. The image at infinity is very small, by the way. It's really, really far. Its size is almost diminished. Okay. But during the earliest time before L1, it would have been a huge advantage, huge disadvantage. Yeah, maybe. Yeah, it would have been a huge disadvantage. Saying that, but the eyes, you must understand, I told you yesterday, right? The eyes evolved from what you say, fish and lower form organisms, which it was getting perfected over time. There was never a stage where it fell disadvantages, because even if it fell disadvantage, that species disappeared. Whoever got the bad mutation just disappeared from the planet. So most species which had terrible vision or terrible some genes didn't survive, didn't make it. So we are the best of the best. They say nature is the best bioterrorist, right? It keeps killing us to a point we become better, okay, through evolution processes. So yeah, anyways, that's about the eye. I don't think I have to explain more. But if you remember, this problem, which we did yesterday, was exactly about that, this problem, if you can see. I asked you guys, let's say the person has a vision such that he can place any object which is at 90 centimeters on the screen. Okay. I won't be able to explain that. Sorry, cooling thing. Okay. Yeah. So it's formed at 90 centimeters. Okay. If the image is before 90 centimeters, the person can see, can focus on this thing. Now, the way people achieve, if the object is placed at infinity, if the object is placed at infinity, let's say, really, really far, people use a focal length. People use a focal length such that this has a focal length equal to the furthest point minus this distance. Hope you guys got it. So if a doctor has to prescribe a focal lens for you, first the doctor needs to know what is your furthest point. Okay, if your furthest point is 90 centimeters, it's terribly drawn out of scale, I understand. If this is 90 centimeters, if it's really, that's why we use arrows, Muralidhar, okay, to indicate values. Okay, so if you are 90 centimeters away, let's say 90 centimeters, your furthest point, then what should be the focal length of the concave lens that has to be prescribed by a doctor? Can anyone tell me? Here in this case, what's the focal length? To make sure the image is brought from infinity and placed here. 89, right? We did it yesterday. It was 89. So then we knew how much was the, we can calculate then how much is the power of this lens. We can calculate what is 1 by minus 189, 1 by minus 89, and you'll get the power of the lens. So my point is your power is decided based on where your concave lens places the image. Now, I know some of you are wearing spectacles there, okay? And some of you have concave lenses there, okay? I think they are not exactly concave lenses, but if possible, take a torchlight, take parallel beams, rays of light. Your torchlight produces parallel rays, right? Pass it through your spectacles and see where those rays meet, okay? With the person with the power of 7.5, you know how much is the focal length of that, okay? If it is 7.5, roughly we are talking about, by the way, yours is a concave lens, so virtual image it will be formed. Do not forget that. It's going to be a virtual image. So it won't focus the rays. The rays appear to come from a particular point, a specific point. Okay. Yeah, that's about it. That's about it. There is one question I had. This is a very difficult question, Arjun. Yeah, torch rays aren't precisely parallel, but they're close enough. Okay, they're close enough, so we can use them as reference. Whoever has I think it's called hypermetropia, right? They can test this hypothesis. They can check for this, okay, by using a torch. You can see the rays focus. Okay, I discussed this. We discussed this. Yes. Now this is a very important point. I think I made this. See, for most part, and I want to clarify this. I know that eye is a third lens out there, or a second lens, or another lens out there. For most part, whenever we discuss about problems, we do not care that the eye is another lens, because it doesn't matter, because the eye will adjust everything needed to form the image on the retina. Okay, for most part, the eye can deal with it. It will form the image on the retina. So whether you won't get a blur, nothing happens. The focal length is adjusted or something like that. So you can simply ignore the effect of the eye. But, and this is a big but here, okay, but it depends on something else. When you get the lens very close to the eye, you have to take into account that your eye is also another lens. Okay, and I started a discussion on Schoology. I don't know, you guys have time till tomorrow to discuss this out. I think I posted it on somewhere. I don't know. Muralidhar was the first one to comment somewhere. Did you guys get this? Did I speak about this thing? I think some of you saw it, about the Desmos this thing competition. Yeah, the big but, I'll come to it. But if the lens is very close, then you have to be very careful about dealing with eye as ignoring the eye's lens. Okay, that can lead to some confusions. I'll come to this in some time. Okay, if it refracts even more than what the lens refracts, it retracts even more. Nidhi, I didn't get that. You'll have to type it properly. Okay, so discussion is somewhere here. I don't know whether you guys got the discussion. It's somewhere in your this thing. Why does the lens blur? And I think, yeah, Pratyush also has answered something. Cool. Yeah, Muralidhar has answered something. So you guys can reply. I don't think you will see each other's replies, or maybe you might see them. So keep posting them. That's a discussion to share links and ideas. I'll give you enough time. Think about it. Okay. This is, I understand you guys have your own perspectives on things, but there are many ways of answering the same question. Earlier, I asked you, why does the concave lens is used for myopic patients? And some of you told that the rays diverge. But there was one more way Nidhi looked at it. She told that the image from infinity or further away is placed at the furthest point of the eye. So that's a different way of answering the same question. Okay. So I'm looking for different ways of interpreting the questions that I'm putting at. Why does the image blur? Okay, that's what I'm getting at. I'm not looking for one answer. There are many answers for this. Okay. Yeah, until you reply, you cannot see each other's posts. Yeah, I think so. By the way, do you see each other's replies, by the way, Pratish and Muralidhar? Did you see each other's replies? Oh, you guys can see. Okay, I'm not restricted you guys from seeing each other's replies. But I think until you post, you cannot see, right? Can you see it on your Schoology group? Can you? Okay, by the way, I want you guys to open Schoology right now on your browsers. Can you? Please open Schoology right now. We need it. That's why. Okay, you guys can reply. Others also can see, I think, discussions. Okay, so I'm testing Schoology for the day. I'm trying to see what I can, what you say. Yeah, so please open Schoology. Go to your Kalpana Chawla, whatever this is. How many of you are there? Can you give me a yes or no if you reach there? Okay, cool. So there's a question coming up soon. Okay, you guys are there. So there's about Desmos thing. Yeah, you guys can see the replies. Then cool. Have your discussions there. Okay, keep it open. Have your discussions there. I'll get back to something else in some time when the discussion, once this PPT thing is done. Okay. Desmos art contest is you have to draw graphs. You know Desmos, right? It's a graph plotting software, and we use that in math a lot. Okay. Particularly, I think there is some games also which are designed using for graphs, mathematics. I think Vinton is become trigonometry, right? You guys need to check out something called. I think I'll post it later. I'll post it later on Schoology if I get it. Okay. Yeah. Going ahead, 1 second. I need to share you this. Okay. Yeah, you guys can see. Now, I think I told you about the muscles and myopia I explained. Yes. Okay, I have a question. Are there other ways to correct myopia? Do you think there are other cool ways to correct for myopia other than using a concave lens in the front? Yeah, Ashay, I think so. I don't know. Yeah, many are saying contact lenses, but the contact lens is the same thing. It's just a lens. Yeah, doing something to the laser treatment exists. Yeah, there's something called laser treatment and many other approaches. But do you see if you stretch the lens, if you can somehow figure out a way to stretch the lens a little bit by eye surgery, as Satvik suggests, or a corrective surgery, yes, you can achieve the same thing. Bifocals actually don't do much. Okay, bifocals. Yeah, use a concave lens. Laser treatment. I don't know how laser treatment exactly works, so I don't want to speak about it. But I know that laser treatment works the best. Okay, you can check out some YouTube videos on it. If possible, I'll try to find one. Okay, laser surgery. Okay, I want to go ahead. This is good. So if you can somehow figure out how to stretch the lens using these muscles, you can still achieve it. But considerably, I think, yeah. But the danger is you don't want to play around with these muscles because these muscles are very delicate, and you don't want to damage them or do any crazy things with them. Okay, so you better off with the what you say a lens or a concave because it's the cheapest and the easiest way to go about. What is the refractive index of the eye? I do not know either. Can you Google and let us know? It's on some other tab or something like that. Oh, okay. I'll search. Anyways, we are there. Refractive index of 1 second. You got it? I'm also trying to search. I've shared this thing, I guess. Yes. It says somewhere it varies. It varies. It has different layers, by the way. Okay. It has varying refractive index. It goes from 1.406 to 1.3 in the dense layers. Okay. You need to read about something called optical fibers. You guys know optical fibers, right? Read about something called multi-mode transmission, something called multi-mode transmission. I think I told about last year, where the refractive index keeps changing continuously. Okay, refractive index keeps changing continuously. Okay, so it uses something like that. Okay, I have a question for you guys. I don't know whether this has been asked before. How many of you know about the brachistochrome problem? I think it's called brachistochrome. Yeah, I think so. How many of you know about it? Okay, here's how the problem goes. It's simple. Don't Google about it because you'll get some answer. Yes, I'm asking about a problem. 1 second, Nidhi. I'll explain it onto the screen. 1 second. I'll have to go back to the presentation if possible. So, where is it? 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 Damn it. Okay. black screen. Now you can see here, let's say there is some point A. I think I've explained this before, point A, and then there is a point B here below. Okay. Now you have, let's say, a ball. You have a ball here at point A. The world is two-dimensional. Nothing is different here. This is a flat world almost. Let's say if I had a rope, let's say have a rope like this, a ramp like this. Okay, a ramp which goes something like this. Okay. Now if I place a ball and if I roll it, what happens? It reaches B in some time because of gravity. Hope you guys agree with that. Okay. Now let's say we have a situation A and we have object same point B. What happens if I make the ramp really flat? What happens? Will the object come faster or will it take longer to reach B? Which one do you think takes longer? Is this the one that takes longer or this one takes longer? The second one, this is the second one, this is the first one. Which one takes longer, do you think so? Okay, you guys, some of you agree that the flat one takes longer. Okay, the brachistochrome problem is, the brachistochrome question is something like this. If I give you point A and if I give you point B, okay, and A, point A, which is that curve? Oh yeah, do you guys think this one will take longer? Do you think this one will take the shortest time? The third one that I drew? That is a strange one. That will, obviously the ball may not reach there only. It might jump off and do crazy things, but may not reach there. Okay. So the question is, which is the curve out there that takes the ball from A to B with the help of gravity in the shortest time possible? Does this remind you of something called Fermat's principle? Something like Fermat's principle. Yeah. So the point is, the question is, if you have point A and point B, the question is, which is that curve that takes you from point A to point B with the help of gravity in the shortest time possible? Is it the flat one, which goes straight away like this? Is it the L-shaped curve, which goes something like this, like a rectangle? Or is it this one? There could be other curves also, where the ball could roll on the top and then fall very quickly. Yeah. The question is, what is that curve? And that is related to something with what I was speaking about, the refractive index changing. Okay. So that's why I mentioned this here. Okay. It's a very, yeah, many are suggesting it should be a C shape like this. Okay. Turns out it's kind of right, but it's not exactly right. Some are suggesting it should be this curve. Okay. Read about this because this curve is crazy. The answer to this problem is very crazy. Read about I think, yeah, that's called multimode transmission previously. I think it's called brachistochrome problem or something like that. Okay. Curve formed by acceleration of gravity. Yeah, the question is, what is the shape of that curve? Okay. Which path should the ball take so that it reaches the point B in the shortest time possible? Does that ring a bell with Fermat's principle? That's the question. Okay, it's connected. It's connected. Okay. Now going ahead, I think that was more than enough discussion on it. Yeah. Oh, this, how many of you watched this minute physics video, how to see without glasses? So if you lose your glasses at some point and let's say you can't see anything, you should be able to still see things. Okay. The idea suggested in the video, please check this out, whoever wears spectacles. This can help you a lot if you have very high power specifically. What it says is you have to, get your fingers very close so that you create a pinhole with your eyes, with your fingers, pinhole, almost like a pinhole. And then place that pinhole very close to your eyes. If you create a pinhole with your fingers and place it close to your eyes, that pinhole acts like a something that creates a pinhole camera-like structure. It acts like basically almost like a lens. Okay, so you should still be able to see it, but I won't show you the video because it will take longer. But it's out there. Okay, do check it out. I'll probably show you other videos, not this one. Okay. Yeah, now tell me, here's a question. Something is placed at 500 meters, 500 centimeters. Yeah, you guys can try it, okay? And there are two lenses, one which is of focal length 10, the other one of just focal length of 1. It is placed at a distance of 10.5 centimeters. Where is the final image formed? Where is the final image formed? Calculation. No, Muralidhar, that's not the curve. Okay. Where is the image formed? From the second lens. Okay, now do not answer here. 1 second, I'll have to do something. Give me a moment. Do not answer yet. Do not answer yet. Keep your answers. Okay, 1 second. I'm gonna try something, that's why. Okay, go to your Schoology. Okay, I can hear sounds. Okay, go to Schoology and check out. There is a something that has been updated. Can you guys see something called object far away two lenses somewhere on Schoology? Can you see it? How many of you can send me in the chat at least if you can see it? No, it has been just published just now. So can you see it? I'm gonna try this. I don't know if this is Schoology is very annoying when it comes to these things a little bit. Can you see the assignment? How many of you can see that? Yes, yes. You have to answer there for me. Okay, quickly. Answer there. Okay, on Schoology. Just see. I just want to test whether it works really well. Otherwise, I'm gonna just stick to chat boxes itself. Okay. It's called object far away. I'm looking for your answers. You can type your answers there if you can see it. It's I think in somewhere in updates or something like that. You should be able to see it. Where do you check? I do not know. Can anyone tell me where did you guys find it? Can you tell me where did you guys find it? Whoever found it? Yeah, I think Mithil replied. Some of you are replying. Some of you found it. Where did you found it? It's in the notifications. It's in the notifications. Okay, it's in the notifications, guys. Or it's in the physics folder classes or something like that. Yeah, classroom discussion. It's in physics folder under your materials, under class discussions. I'm just testing this, okay? Do not answer in the chat. Answer me there. Okay, because this has one advantage. We can see, we can track your replies during classes, but I'm trying to make it more efficient. Let's see, next time we'll see. This is a trial class today. I'm just going to test this, whether it works. Okay, I have answers coming in, but it's too slow, guys. You guys are answering very slow, or you've not solved the problem. Okay, 1 second. Still solving. Okay, some of you are still solving. Okay. How many of you finished answering? If you're finished answering, do let me know. It takes time. Okay. Use a calculator if possible. This is an annoying problem a little bit when it comes to that. Okay, I'll tell you who and all are right. None of you are right. I'm sorry, none of you are right. How bad is your approximations, guys? Yeah, some of you finished answering, but your answers are wrong. Look, I think I could be wrong. 1 second, I'll check. I'll just have a check. Look, the answer must be negative. Hope you understand that. It's going to be negative a little bit. Okay, this is terrible. It's not so great. No. Okay, 1 second, 1 second. I'll just do something. Okay, I can hear some sound. Yeah, nice sound. That's good music. I'll have to mute you guys now. Okay, cool. Some of you answered. Okay, let me tell you. Wait, who and all are right? Sucks. Nope, nope. I think the only person that's right is wait. Uh, nope, wrong. Sorry. I thought that was right. No. Wait. Come on, no one has given the right answer. None of you. Now I'm starting to think I'm wrong somewhere. Okay. You guys are answering on Schoolage, I believe. New answers have come. Nope. Nidhi, you're right. Yes, Nidhi is right. Nidhi, that was right. Okay, this is taking time. Okay, I'm sorry. Schoolage is a little bit longer. I think I won't use this. Nidhi, your answer is very close. That's all I'm saying. Nope. No way. No. Okay, I don't get real time. This is not real time. It's annoying. Nope. Nidhi's answer is the closest one. Rest everyone is off. Nidhi, your earlier answer was close, not the new one. Okay, I think you messed up a little. Okay, let's just see. Maybe I messed up. Okay, let's see the calculation. I could have messed up. I don't know because there are varying answers that I've reached a point where I'm thinking maybe I'm wrong. Okay, one shot. I'll give you next like half a minute. Enter all the answers you can think of, whatever you might be getting. It's the same formula. Okay, nothing has changed. How come many of you are answering minus 9.03? A significant portion of you answering that. I mean 0.903. Yeah, there are more and more people answering that. And I'm starting to think I'm wrong because of that part. But let's see. Okay. Maybe I'm wrong. Okay, I'll just look into this. Wait, let's see. But none of you other than Nidhi have given the answers which looks like mine, or maybe some of you have given, but it's not in some fraction format that's confusing me. Okay, really sorry. I'll just show you what the answer is. Okay, I'll just get back to this thing. Listen up. I could be wrong. I'm warning you again. Just correct me if I'm wrong somewhere. Okay. The first one is at 500. Hope you guys know that. The object is placed at 500 centimeters. So the first image, where's the first image form? Hit me in the chat box, not in this thing. Hit me in the chat box. Numbers in the chat box. First image, where's the first image form? Yeah, Keaton, you're right about that. That part is correct. Can you guys give me the answer? Yes, Mithil, all of you are right, but no. No. Some of you are giving me the reciprocal of the answer, not the answer. That's where you guys went wrong. Some of you are giving me the reciprocal of the answer rather than the answer. Yes, Nidhi, that's right. Yes. Yeah, Navya, that's right. Shashank, that's right. Yeah. The first image is formed at 10.02, or Satvik, you're also right, yes. The calculation went wrong for some of you. Understand that the image is formed there at that distance, 10.02. Whoever got this in the first stage is bound to get rest of the things correct. Is this calculation correct? Can I believe you guys can verify this. It becomes 5,000 multiplication and it becomes 10 minus 500, so it gives you that. Okay, don't want to mess that up. Okay, next, what is the input? 0.3. Hope you agree with that, because 10.5 centimeters is the distance between the lens, so the input is just 0.3 centimeters. Okay, now proceeding ahead, if you go along with this calculation, you will get the images formed at a distance of 3.09. And I think Nidhi gave the answer as -3. That was close, so I went with it. But I don't know about others. Is there something wrong with my calculation? I don't think so. I personally don't think so. There's something wrong. Uh-oh. Damn it. Okay, that was my mistake. I'm really sorry. Okay, I was supposed to keep the focal length as 10 here. I'm really sorry. This was supposed to be 10. It was a typo. Yeah, gotcha. Yeah. If it is 1, what do you get answer as? If you get 1, if you type 1, what do you get as the answer as? If you type 1 there, you're going to get minus 0.3 and 1 minus, so 0.7 by 0.3, or 0. Or you get 7 by 3. Whoever gave 7 by 3 in the beginning was right. I think 7 by 3 was right earlier. I'm sorry, there was a typo here. This was 10. This was supposed to be 10. That was a mistake. Okay. Yeah. 3 by 7 or 7 by 3? I think so. Yeah, 3 by 7. 3 by 7 was the right answer. That is 0.42 or 0.43. Whoever gave 0.4243 were right earlier. That includes, I think, Sumedh, Muralidhar, and many others who are probably angry at me right now. Okay. Anyways, going ahead. Okay. So the image is formed somewhere there. If you go by a focal length of 10, the image is formed there. Okay. Now, what do you think I'm getting at? Can anyone tell me what do you think I'm getting at in the chat box with this? Has anybody have any thought about it? Okay, can you agree that the final image formed is virtual? Okay. Now, yes, I agree. The image is formed virtual. Okay, I have some questions for you guys now. You've seen a telescope, right? Yeah. Now, how do you see something that's really, really far? That's the question. How do you see something that's really, really far? Like a star or something really, really far. How do you see it? Can you come up with a strategy to achieve that? Remember the strategy that you used long back. Remember the strategy you used long back. Remember that strategy for the myopic person. You did something amazing for the person who was myopic. You did something interesting that made the person see. You projected, yeah, kind of, Nidhi, but how? See, the problem with the object at infinity is that it's really, really far. How do you see something that's really, really far? What's the step to see something that's really far? Okay, how do you see something that's really far? Tell me, first of all, how do you see something which is really, really far? There are two choices, two options. Do you realize there are two options? First one, make the object really big. Can you make the object really big using a lens? Can you magnify an object using a lens? Yes. So you can do that. But if I use a magnifying lens on this star, you see, I can't focus it because it's that far. Okay, I can't magnify this star because it is really, really far. It's not within the focal length of my lens. Agree with that? See, to magnify an object, you need to have the object within the focal length. That is not happening. So how do we achieve it? Give me a step-by-step process of how to achieve it. What's the first thing you could do? You could bring the object from infinity and place it close to you and then magnify it. Are you guys getting that? You could bring the object from infinity, get it close to the lens, which can help you magnify, and then magnify the image using that second lens. Yeah, like we did with spectacles. Earlier we did spectacles was slightly different. With spectacles, we're getting the object from infinity and placing it at the far point of the person's eye. In this case, we're placing it just before the focal point of this thing, within the focal point of the second lens. The reason why we're doing it is we want a magnified image. Okay, Observe this, okay? This will probably help you understand. I think there is a link itself which can help you. So let's just say we have, 1 second, where is this? Yeah, Schoology answers came in. Anyway, so if you have an object which is really, really far, let's say, really, really far. I don't think this is a great thing, but 1 second. Okay, 100, yes. Where is the move view button? Yeah. Now, if this object is placed, okay, this is not a great system. Okay. Copy paste this. Yeah. Now you can see there are two lenses there. Now the problem is if you use the, see if the object is really, really far, like crazy far, let's just say we'll go much more further. You can't see it. It's like crazy far, right? You can't see it. Yeah, answer it here only, okay? Answer here only. So it's very far. You can't see it. So one strategy is if I can bring it close and place it here, and then use another magnifying lens and keep it within the focal length of this. Look, there's one problem. Okay, understand this carefully. This object is really, really far. Agree with that? Okay. The image is formed here. Can you see this image? Can you see this image? Is there a way to see this image? What is the height of this image? Can anyone guess the height of this image? Is it really large? If it goes further and further away, what happens to the height? It's extremely small, right? So how to make it larger? Can anyone tell me? Suggest an idea to make it large. So if you view this, you can't see anything. It's really small. Yes, if you get a, you know that a concave lens, if a convex lens like this one acts like a magnifying lens if you keep it very close to the object. Agree with that? If it's between O and F. Agree, if I place this lens between O and F, I can magnify this image. So what we do is we end up doing that. We get a more magnified image here. The first image that you see, 1 second, I have to delete this lens. Uh-oh. Yeah. My point is, I'll be able to create a very large image using the second lens. I hope that adjustment is proper. But you can see I've produced an even larger image comparatively. This image height is something, but I think I have to go much further. Yes. So I've created a larger image using this another second lens. The second lens acts like a magnifying lens for this image. Okay. This is how telescopes work. The telescopes work such a way that the image formed by the object that's far away will be produced at the focus of the first lens almost. And that image will be formed within the focus. Yes, it's related to the previous problem. I was doing exactly the same problem. That image is formed within the focal length of the second lens. Okay. Yes, you'll be seeing a virtual image. This will be a virtual image. In case of a telescope, you're seeing a virtual image actually. The image will be inverted. When you see through a telescope, image is always inverted. I don't know if you've seen. How many of you seen through a telescope here? How many of you have a telescope or been close to them or anything like that? Yeah. Okay, some of you have seen it. Yeah. So you know the image is inverted. So this is how they produce it. Okay. The problem earlier which I did, okay, if you haven't never seen it, please visit CFL's telescope also. I think you guys have visited some of telescope stargazing at CFL, right? It has an astronomy group and there's a big telescope. In fact, CFL has one of the biggest telescopes in entire Mangalore right now. Okay, the second one is at Aloysius, which is good, but the largest one within Mangalore city limits is at CFL itself, and they're building the dome right now and still in progress and stuff like that. There's one bigger one at I think Mudabidre, Mahavira, I think somewhere, yeah, in Mudabidre in a school, but then they don't use it often, and I think it's spoiled now. It's spoiled. It's not in Alvas. No. Alvas isn't capable of such things. Okay, it's somewhere else. There is one, but the problem is I don't think it's what you say. It's not functional now. It's spoiled. There's one in PPC, but that's not big. I think the biggest one is 14-inch one. They advertise that 14 inches very powerful, that you can see almost Mars in a bigger zoom comparatively. The one we have at CFL, I think, goes up to 10 inch or 8 inches. The one at Aloysius is 8 inches. I know that part very well. The good news about CFL is CFL has two telescopes, big ones, and also with enhanced, capability for photography, astrophotography, which is something no one has at this point in Mangalore. Okay, other than some amateur astronomers. Yeah. Okay. So going ahead, one second, I have to show you something else. So I hope you guys got that. So if you look at the previous problem, this object, which is really far away, okay, very far away, is brought within the focal length, of the second lens, and then it's magnified. Okay. So the whole game of astronomy and all this stuff is to get everything from, like, is to bring objects where they are, the image, from really far, and place it somewhere and play around with it. Okay. When we do this, we lose out on certain things. We might lose out on clarity because magnification is too much or less or something like that. But we optimize for all of these things. That's my point. Okay. So I hope you guys got how a telescope works. Can you get a yes or no now? I've not asked you guys for a yes or no since a long time. Did you guys get this? Okay. Okay. Cool. Okay. So continuing on with the presentation itself. Yeah, this is basically the idea. This is called an ocular lens or objective. This thing. What is that? Yeah, this is the objective lens. This is a large lens that is used, and this is called the eye lens or eyepiece, or also called the ocular lens. This is the lens through which you view objects. Okay. So the first image by the ocular lens is formed here, inverted. Now, can anyone tell me why is this lens very big compared to this one? The first lens, bigger compared to the second one. In height, not in focal length or something. Why is it bigger? Taller. Why is it taller? Yes, Muralidhar is right, Nihad is right. You have to capture, no, it's not to make thinner, it's to capture more light. If you look at the object that's coming from infinity, it will be very dim. We are getting probably 2 or 3 rays from it almost. In angular resolution, we are getting very few rays from it. Okay, if the object is very close, we'll get almost most of the rays, so image formed is very not so dim. Okay, but if the object is really far, we're getting very less rays, faint rays. So in order to create make sure we gather more light, you have to use bigger and bigger lenses. So the question is, how big can these lenses get? Can you go on making the lens really, really big? Okay, in order to see galaxies, you might require bigger and bigger lenses. Okay, so this is where there's a limitation for the telescope. We can't go on building bigger and bigger lenses. So we have come up with a much more genius solution. Can anyone tell me what is that? Galilei used these kind of lenses, but they came up with a better solution. Rather than using, no, they didn't use prisms, they used something else. They started using something that can capture more light. They can capture more light, not digital zoom, that's Samsung. Okay, so they didn't, yes, Nidhi, you're right, they use mirrors. Mirrors can be made really big, one. Second, mirrors also can act like a concave lens. See, a convex lens, if you think about it, can be mimicked by a concave mirror. Concave mirror also focuses the light. So we can use them to capture the rays. So lens, to make lens bigger, it's very hard compared. You have to grind these lenses. Okay, but mirrors can be made as large as possible. So here's an example of how a lens works. I think a telescope I explained, right? The image is formed here first, and then, uses those rays to form a larger image of the chocolate or whatever. Okay. Now, leaving that aside, I think this is the explanation for it. I prepared last year, so it's fine. So if you have the moon, let's say, and you're trying to view the moon, the rays which come from the top of it are going to travel a lot. And I think this is going to be an animation that's going to take really, really long time from my side to reach. But I think this should explain what's happening. The rays are coming from really, really far. So the rays that come in are almost parallel. But by the time they reach the lens, they're almost parallel. Okay. And you know what happens to the ray out through the optic center? It goes straight away. And this ray almost comes parallel and hits the focus and then goes out parallelly to the principal axis. And they meet there, and that's where the image is formed. Okay, this is where the image is formed. But here's the most important part, and I think I tried explaining this. You have to keep the second lens within the focal length. The image should be formed within the focal length of the second lens. Okay. And if you achieve that, you can get a larger image of the moon, which you can see. So this is essentially how a telescope works, one more way of looking at it. Now, this is the point I wanted to make. They use mirrors nowadays, okay? For most part, people have switched to using mostly mirrors. In general, like you could end up using, what to say, many other things for telescope viewing. But preferably now we have switched to mirrors for large telescopes, because the advantage is you do not need to have continuous mirrors. Mirrors have to just gather light. This mirror has to gather the light, gather the light, gather the light. All of these will form the image. All these, each of these mirrors can form the image and combine them together, giving you more brightness. Okay, all of them will form the image at the same point. So essentially, you can end up having large array of mirrors, like huge array of mirrors, capturing so much light that we can get pictures of galaxies, and probably I think Kepler telescope can see right now planets going around other galaxies, other stars. Okay, so we have kind of achieved these things using these approaches. Okay, there's one at Aloysius. I think I mentioned this. This is, I think, the earlier one was. No, I don't know this. This one I've forgotten where I took it from. Do check it out. There is something called large. I forgot, large something. Some mirror telescope. It's very big. It's I think in Hawaii. Most of the telescopes are built in Hawaii because of good weather there. This is one at Aloysius with the dome. It is a very oldest one. It's the oldest one in Mangalore with the dome. CFL is getting a dome soon, and it'll be the most sophisticated dome in Mangalore once it's built. Yeah. I hope you guys know about the Samsung's 108 megapixel and with 30x telephoto lens, which is becoming popular a lot in these days. Most of the cameras these days are coming up with what you say, lenses that can magnify crazy lot. I'll speak about this tomorrow and continue with the what you say. Yeah, now this is not fake actually. What? Yeah, even Huawei uh, produces a similar sensor before. They did it. Yeah, they have a 10x optical lens, optical zoom. The way they achieve that is crazy. I'll come to that in some time. Okay, tomorrow I'll discuss it. Kinda, I'll discuss it tomorrow. Okay, 1 second. Yeah, the 11 Pro doesn't have it. I'm sorry. iPhones do not have it. They will announce it sooner or later, probably. Okay. Yeah. So that's about it for the day. I'll see you guys tomorrow. I'll probably try to increase the speed of the presentations as well as everything. One more thing. I forgot one more thing. There's an assignment, second micro DPP. The first one will be corrected. Most of you have submitted. There'll be a new one which will be going live today. Okay. It's ready to go live. I've just not posted it, which means it will be published. That's what I meant when I said going live. Yeah, I'm going to do it right now. 1 second. I think it's here, micro DPP. Second one, it's here. This is the thing that you have to publish, submit. Your deadline is tomorrow afternoon. Uh-oh. Okay. You guys don't have to do this. Sorry, it's going to take some time. I'm sorry. I'm going to unpublish this. I'm gonna make you guys do this tomorrow, because there's one problem out there which needs to be done before I can give you this DPP. So tomorrow you'll have the DPP, okay? Or you guys can, okay, start submitting. Okay, I'll publish. Start submitting. Okay, whoever wants to answer, do answer this. These are the questions. 2 questions. You have to answer both of them. Okay. This is the second DPP, and your submissions due date is tomorrow. No, I'm going to change the due date to day after tomorrow. Okay, like probably 29th or something like that. Don't worry. Okay, but you guys can start submitting. Okay, so that's about it for the day. Thank you for joining in. I have another class, so I'll try to increase the speed of these presentations and everything, but I think Schoology will weigh me down a little bit, but let's see. Okay, yes. As a 10x optical zoom, I know about it. Yes, Mohammed Nihal, yeah. Okay, I'll edit that. I'm sorry. It was his or her. Okay, here it's his or her lens, eyes. Okay, I'm sorry. I'll edit it. Okay. See you guys. Okay, that's about it for the day. You can solve the first problem. First problem is easy. Okay. Yeah. Bye bye. There's another class. Google Classroom. I won't use it. I'm sorry. Yeah. Bye bye. Bye bye. See you guys. Some other time. We'll have a discussion some other time. Yeah. Bye.
Good evening, students. Can you hear me? Am I clear? Okay, let us continue then. Yes, so it's clear, voice is clear. Okay, so today we'll be starting with a new So that's it. So now let us continue with the polynomials. But before we start with the polynomials, let us go back to the very basic concepts which you have learned in your lower classes and then you have continued up to 8th, 9th and all that. So now why am I doing this? The reason is we need these basic concepts as we proceed with the other higher concepts of higher classes. Now, actually, under this polynomials topic, we have a lot of things which has to be discussed. That is nothing but first we'll be discussing about the relationship between the roots and the coefficients, all that, and also we have the graphs which will be drawn using maybe GeoGebra software. I'll be asking some of them are not able to hear audio clearly. Is it? Okay. Is it clear now? Not clear. Voice is breaking. Okay. I think there is a okay. It's too fast. Okay. Now, are you able to hear me? Yes. Okay. Now we'll be discussing that, and also we have to discuss how to plot the graphs for the given polynomial. That also we'll be discussing. Okay. Yes. So once in order to do all that, we need a very basic few concepts. Okay, so we'll be doing that. Now let us move on to the very first basic concepts. So what I'll be doing is I'll be giving you certain expressions. Okay, and you know what are they, right? So these are this is what we have. You know what are these called as? I've just given you expressions, but they have a certain name. What are these called as? Anybody can tell me? If you want, you can raise your yes, polynomial. Okay. More precisely, what you have learned is algebraic expressions. Yes. Some of the yes, most of them are correct. That they have named certain types also. Yes, very good. So these are like more precisely, these are nothing but these are called as algebraic expression. Okay, this is what is the basic things which you have learned. Now you can see there is only a single term here, and then there is a number here. There are two terms, there are three terms, and there are four terms here. Correct. So now, what is this? Why we have these are classified, that is, algebraic expressions are classified on the basis of number of terms. We'll be discussing about that classification in few moments, but now, before that, you have to remember in an algebraic expression, we have different combination of things. That is, if you observe this algebraic expression, for example, it has variable which is x, and then we have arithmetic operator which is plus. Not only that, you can see here this is 2x, actually 2x, it means it is 2 into x, it is. It is not just a 2x, it is 2 into. So this is nothing but again it is an arithmetic operator. Here you have a algebraic expression, it is nothing but it is an expression, or we can say it is formed using variables, constants. Now where is the constants? Constant, this 2. Actually this is, okay, is it audio is a problem? Okay, hard break. So most of you are not able to hear audio clear, is it? Oh, okay. Audio. Can you hear me now? It's clear? Okay. So, is this taking press? Okay. I think there is a little bit of problem with the internet. I think today it is not. Sometimes it just slows down. That's why I think it just uh, having a problem. So okay, let us see as we move on whether you are able to hear it or not. Okay. Yes. So as I was discussing, yes. And about the trigonometry, yes, sir, will be continuing it on Wednesday and Thursday. I've already mentioned it. So now let us continue with the this concept here. What we were discussing, that is nothing but algebraic expression. Now, as I was discussing here, you have to remember algebraic expression is nothing but it's a combination of variable, the numerical terms, what you call it as constant. When I say constant, I'm not talking about the constant and the coefficient in an expression. In general, a numerical terms, what you call it as constant. And then you have the arithmetic operators. Combination of all that is called as algebraic expression. And remember, when it comes to the coefficient and constants, here the number without any variable, that is called as constant. And if you have any variable here, so if you can see 4 is without any variable, that is why it is called as constant. And now when you see here x square, it is having variable, so it doesn't have any number, that means it has its coefficient is 1. Please remember this small things, but it is very important. Okay, so that is what is the difference between the constant and variable. Now, basic classifications we have based on the number of terms here. Already some of them have answered here. Now, others, can you tell me what are the classifications we have for algebraic expressions based on number of terms? Okay, some of them have answered quadratic and cubic, but to be frank, quadratic and cubic are based on certain other things. Yes, 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 monomial, binomial. Yes, good. So it is nothing but it is the monomial, binomial, and trinomial. Now, what is this monomial? A term or a algebraic expression which has only one term, like this x, that is called as monomial, or 2x power 4, that is called as monomial. A term or maybe, okay, so here you can see x square. Oh, 1 minute. Okay, here you have x square plus 2. x. This is having two terms. That is why this is called as binomial. And when you have terms, it is called as trinomial, and after number of terms what we have here. Okay, so please remember this is based on the number of terms. Okay, next we'll move on to the next. That is nothing but you have to remember here, these are the small definitions, kindly note down. And you may have a question, why did I mention here the polynomial when I was talking about the algebraic expression? Remember, these algebraic expressions in general are called as polynomials. This is what is the general name. That is why here I have taken it as polynomial is the one of the polynomial of one term instead of algebraic expression. I have done that. Okay, so there is nothing wrong. You just have to remember algebraic expression is nothing but it is the polynomial itself. As we go to higher classes, we never say algebraic expression as such. We'll be using polynomial of fourth degree, polynomial of third degree, all that. Okay, yes. So next. Next concept. So please remember the students, monomial, binomial, and trinomial. If it is more than three terms, it is called as the polynomial. Please remember that. Is it clear now? Audio? No, it's not clear. Students, properly? Am I clear? No, it's not. Okay. Is it the okay? No, sometimes it breaks. Okay, it's too far. Okay. Oh, it's really bad. It gets compressed. Okay.
Let's
Here,
complete.
here, what I was telling you is remember the polynomial. Now, remember why I have used polynomial? The polynomial is nothing but I have to tell you it is the general form of the algebraic expression. It's very important part. You have to remember as we go to higher classes, we never use the term called as algebraic expression, except for 1 or 2 marks questions or something like that. Maybe in a very rare cases we may use, but other than that we'll be using polynomial. That's why in the definition also I've mentioned a polynomial of one term is called monomial, a polynomial of two term is called as binomial and trinomial. Okay, then more than three terms it is called as polynomial. Please remember that. Okay, next we'll move on to the next one. That is nothing but it is the classification based on, some of them have already told me that classification. So now here that classification is based on the degree. So what is this degree? Degree is nothing but it's the highest power of x in p of x. Now what is this p of x? That is nothing but the polynomial. For example, suppose if I write x square plus 2x plus 1 okay, so this one here the highest power of the variable is 2. The highest power of the variable here is 2. Okay, yes, my answer. Remember, this 2 is here called as a degree polynomial. Okay, so now let us continue. So this is
Can
what
you
we
hear
will
the
call
audio?
degree. So highest power of the variable is called as the
What?
This is about the degree. So remember, it is the highest power of the variable. It is not the highest power of the anything else. So you have to remember this. Okay. So this is about the polynomial's degree. Suppose if I give you root x plus 1. Is it a polynomial? Anybody can answer me? Is it a polynomial? No, it is not. The reason is, anybody can tell me why it is not a polynomial? Yes, most of you have answered. Yes, degree is 0.5. No root for the number. Okay, yes. Okay. Yes, the reason is, the correct reason is, here we have a rule for the degree. We expect the degree to be a non-negative number. The reason is here, whenever I'm not saying that we will not come across these kind of expression. You may come across in future when you go for higher classes and all that. In that case, we will be using the rule that the degree has to be non-negative. That is, it has to be either 0 or it has to be greater than 0. That is the rule we have for the degree of the given polynomial. So that is why root x plus 1 is not a polynomial where the power of the variable, that is the highest power, becomes half. Correct? Yes. So that is what we have. Okay, correct. So this is what we have. Now we'll move on to the next, the classification based on degree. As many of you have already answered, based on degree, we have different classifications. Almost we have 5 types. In general, the fifth one is a general type. Before that, we have the linear, quadratic, and the cubic, and also we have the biquadratic polynomial. Now, what is this? Okay, what is this? Okay, so to hear me, most of them are saying I'm not able to hear. Okay, next move on to the next one, that is classification based on the degree. We have the first one, which is nothing but it is called as linear polynomial. Now, what is this linear polynomial? A polynomial which has the degree as 1 is called as the linear polynomial. For example, anybody can give me, yes, degree 1. Anyone can give me the example? Yes, some of them have answered. Good. Okay, 2x, correct. 2x. Suppose if I just write 2, is it a linear? Okay, we'll come back to that later. Okay, yes, 2x, 8x, x plus 1. Okay, yes. Some of them have answered this question. 2 is, no, it is not. Yes. So we'll be discussing what kind of polynomial is this 2 later on. Yes. So now we'll move on to this one. So what is this linear polynomial is? The number is 1. That is why it is called as linear polynomial. Now, when it comes to the linear polynomial, there are almost two kinds. It need not be like a linear equation in only one variable. We can have linear equation in two variables, even the three variables. Okay, now what is this first one? First one, we have linear equation in one variable, that is just, if I give you example, x plus 1. It's a linear polynomial in one variable. Same way, if I go for this here, 2x plus 3, this is a linear in two variables. And remember, this is a polynomial. Suppose if I want to make it an equation, there is only one thing that has to be done here, that is nothing but put equal to 0. From the polynomial, it becomes a linear equation. Instead of polynomial, it becomes a linear equation because there comes equal sign. Okay, so please remember this. So in order to turn this linear polynomial into an equation, you just have to put equal to 0. Okay, yes. So now that's the difference between the linear polynomial and the equation. Now, before we continue with the next quadratic polynomial, let us quickly recall what is the standard form for the linear polynomial. Now, why am I discussing? Because later on, we have something called as relationship between the zeros of the polynomial as well as its coefficients. That is why we need to learn this. So yes, some of them have already told me what is the standard form of a linear equation. When it comes to the linear polynomial in one variable, it is written as ax plus b. Now, what is this a? A is the coefficient of x. Here, nothing is there. That means it is 1. Here, b is 1. It is the constant term. So, ax plus b is the linear polynomials in one. It's a standard form of the linear polynomial in one variable. Next, we'll move on to the when we have linear polynomial in two variables. What happens? Then it will be ax. It will be, and then since we have two variables, here we'll have by, and then we have c. C here. Okay, yes, some of them have already told me what is it. Yes, exactly correct. It is ax plus by plus c. This is nothing but it is the standard form of the linear equation in two variables. And remember, when you plot the graph, we'll be doing it obviously later on. But before we'll do it, let me tell you, last year also in your classes, you have learned when you plot the linear equations graph, it will be always a straight line. Please remember this fact. It's very important part of it. Okay. Next, we'll move on to the next. So next, we'll move on to the next type, which is when the degree of the polynomial becomes 2. It is called as quadratic polynomial. Now, quadratic polynomial, some of them are examples are already given. Maybe I can take one of them. That is x square minus 5x. Is it a linear quadratic polynomial? Yes, it is a quadratic polynomial. We can have just x square term, or we can have x square minus 5x like this, or even you can have just x square plus constant term. These two types where we can't find x term are called as pure quadratic polynomial. Please remember this. We'll learn about all this, that is pure quadratic and all that later on when it reach the quadratic equations chapter, where there we'll be discussing in detail what are the pure quadratic equation, all those things. Okay. So now, what is the standard form of the quadratic polynomial? It is nothing but it is ax square plus bx plus c. So this is what we have. This is when we this is a complete polynomial. Suppose it to this, if I add 1, then this equation is in standard form. So as many of you have sent, yes, this is the standard form of the quadratic polynomial. Okay. Next, we'll move on to the next type, that is nothing but the cubic polynomial. Now, what is this cubic polynomial? It is the polynomial with the highest power of the variable as 3, or degree is 3. So now example, yes, some of them have given example as x cube plus 1, correct? It is, it is, yes, x cube plus 1, it is correct. Okay. And then we have the other examples also where we can have like this x square plus here x cube plus x square plus x, and then we have 1. This is the complete cubic equation which has a standard form. Okay, based on this we can write the standard form as ax cube plus bx plus cx, bx square it is, plus cx plus 1 is written as d. So this is the standard form of the cubic equation. Please remember this, don't forget It need okay. And remember, as I said, if you are talking about a cubic polynomial, then there is no need of equal to zero. When you will write equal to zero, this cubic polynomial, from polynomial it becomes a equal to zero and it becomes a cubic equation. And when we equate it to zero is whenever they ask us to find what is the zero of the cubic polynomial. In that case only we will be equating it to zero. Okay. Yes. So otherwise, it is not necessary to write equal to zero. Okay. So now, one person questioned me what whether there is any quadratic equation in two variables. So actually, that is your homework for today. One of the homeworks where you will be finding out is there any quadratic equation in two variables which is very familiar to you. You have learned about it. If you have any doubts, you can just go back to your old CFL books and just go through, open the book and check, and you will be able to. Yes, one person has answered. Yes, two of them have answered. Yes, I want others also to uh, give me the answer and also along with the standard form. Okay. Yes. So that please note down that you have to equation in two variables which is familiar to you. I'm not asking you to go for anything else. Two variables equation. It's a very important equation which you have learned last year. That is what I'm asking. I'm not asking you about any identities or anything as such. Okay, yes, identities are there. All that is correct. But I want you to identify that very famous equation. Not only the standard form, there are two forms. I want you to find out both the standard form as well as the general form. Okay, and you will be naming it and you will be tomorrow we will be discussing about those two equations. Okay, so next we'll move on to the next type. When the degree becomes 4, that kind of equation is called as biquadratic. So now what is this biquadratic, where the degree is 4? And this equation has constant term, and I want you to write down the standard form of biquadratic polynomial in your book. You note down what is the standard form of the biquadratic polynomial. You know, right? We have written up to cubic polynomial. So what it will be for biquadratic? You can take A, B, C, D, E. If you have a doubt whether it is possible to take E, yes, possible. And remember, when it comes to math, usually A, B, C, D, E, F, those kind of numbers those are used to represent constants, and we use X, Y, Z, S, U, V, all those things as variables most of the time just to avoid the confusion. There is nothing else. It's just a way of writing. That's it. Otherwise, it will be confusing. We use X and X for variable also, X for number also. It becomes very difficult for us to identify what is a variable and what is the constant. That is the reason we use A, B, C, D, F, and all those as constants, and X, Y, Z, those kind of things as variables. Please remember. So yes, as most of you have answered, the standard form of biquadratic polynomial is nothing but it is ax power 4 plus bx cube plus cx square plus dx plus equal to 0 if you write. But so okay, if you want me to write down because some of them are saying it is voice is breaking. So my question was write the standard form of the biquadratic polynomial. So since many of them are not able to hear my voice properly, I'm writing down this is the standard form ax power 4 plus bx cube plus cx square plus dx plus e is nothing but it is the standard form of the biquadratic polynomial. Now, please remember this. This is a very important part, because later on we will be using the standard forms to identify the relationship between the zeros and the coefficients of the polynomial. Next, we'll move on to the one more very important type. It may not be based on degree or as anything like that, but these are the very important part of the polynomial. That is nothing but some of you told me that time itself what is a constant polynomial and all that. So now we'll be doing that. Now, what is this constant polynomial? Constant polynomial is nothing but it is the numerical values. That time I asked whether 2 is a polynomial. Yes, it is a constant polynomial. Why? Because this 2 can be written as 2 into x to the power 0. That is the reason here this is called as constant polynomial. Please remember this. Okay. It is nothing but constant polynomial is nothing but it is the non-zero numerical values. All these are called as constant polynomial. So example is this. This is the example for it. It is the example. 2 is 2 can be whether 0. No, we have separate section for that. That is nothing but the 0 polynomial. Yes. So 0 is called as 0 polynomial. And remember, when you write 0 polynomial, write it little bigger. The reason is we have the normal number numerical 0. Correct? So we can't differentiate 0 and this 0. So that is why whenever we write a 0 polynomial, we write it little bigger so that we can identify whether it is a number or a numerical. Most of the books use these kind of notations just to differentiate. Okay. Yes. And now what is the zero polynomial? The zero polynomial is a one where all the coefficients have uh, the all the coefficients are zero. Yes. Shashank, you have any doubt? You can speak. Shashank, you have a doubt? You have raised the hand. You can speak. Can you hear me?
Will zero come? Ma'am, can you hear me? Good evening.
Yeah, I can hear you. Tell me.
Will zero polynomial come under constant polynomials?
No, it won't come under this one constant. That is why, as we speak, as I was defining, it is the non-zero numerical values which we consider under the constant polynomial. Zero, we have a separate, okay, where all the coefficients become zero. That is why we can't define the degree of the zero polynomial. Also, it is not possible. Am I clear?
Okay, ma'am. Thank you.
Yeah. Yes. Okay. Okay, now we'll continue with the next one. And remember here, very important point. Murlidhar has raised a question. Is it true that zero polynomial has the degree as infinity? Yes. The reason is we can't define what is the degree. The reason is, see, when I want to write only a quadratic polynomial, what I will do is I'll just write it like this and put the coefficient as zero. But somebody else in the group, maybe I can just think, maybe a Ketan or Pratyusha want to write this as cubic or the biquadratic. In that case, they will have a different degree, correct? So that is why we can't say what kind of degree the zero polynomial has. So that is why we say the degree of the zero polynomial is not defined. And when it comes to the constant degree, as you can see, the highest power of the variable is zero. That is why the degree is 0 in the case of constant polynomial, and in the case of zero polynomial we say not defined. Okay, not defined in the sense not defined in the huge quantity. As we say, we have infinite, we can't predict, right? So it is somewhat close to that itself. But when we can't say its degree is infinity, what we say is we specifically say that it is not defined. Okay, yes. Okay, so I think it is clear now. Constant has to be the, yes, constant polynomials should have the highest power of the variable as zero. Then only it is called as constant polynomial. Okay, yes. So next we'll move on to the very important concept. See, we have discussed different types of polynomial, and also we have discussed the standard form for them. But now when it comes to the general form. How do we get that? Those small standard forms that comes from the nth degree polynomial, or what you call it as a general form. Okay. Yes. So here is the general form of the polynomial. Suppose you want to define a polynomial p of x in one variable x. Its general form is given by p of x is equal to a n x bar n plus a n minus 1 x power n minus 1 plus so on up to the last constant terms. Nothing but it is the general form of comes from this polynomial, that is the nth degree polynomial. Please remember this, and I want everybody to note down this. You don't have to by heart it as such, because you already know what are the general forms of different types. So now here when it comes to this one, just note down, because this will provide you basic for the most of the standard forms. For example, if I want to write just a quadratic equation, I don't have to take anything from here. I'll just put n is equal to 2. And if I put n is equal to 2, I will get it as a2. Here a2 are constant students. You can take any numbers, you can take fractions, you can take negative numbers, you can take any real numbers for an. Okay, so it becomes ax2, and then you have a1 x1, finally a0. You have a not. Okay, so this is what we have, the standard form, what we get from there. But what we do, we don't write a2, it becomes really difficult for us. So that is why what we do is, when we write a standard form, we use it as ax square plus bx plus c, so that it becomes really easy for us to write the standard form. So please remember that. And now here, if you want me to give the example, suppose if I give you here 2x square plus 1. This is a quadratic polynomial. Now what is this? Here this represents the coefficient. This is the quadratic polynomial. This represents the coefficient and this represents the constant term. Same here in an nth degree polynomial. Here an represents the coefficient of x bar n. An minus 1 represents the coefficient of x to the power n minus 1. And a2 represents the coefficient of x square. a1 represents the coefficient of x power 1. And then we have a0, which is the constant term. And here very important point to be noted is nothing but an is not equal to 0. Now why an is not equal to 0? The reason is here very important point. Now I have given you the example 2x square plus 1. So 2x square, instead of taking 2 here, I want a quadratic polynomial. If instead of taking this 2, I will take here 0. Whether this remains the quadratic polynomial? No, because 0 into x square will be 0, only I'll remain with 1. So it won't remain as a quadratic polynomial. Same thing is applicable here. Nth degree, if you want nth degree polynomial, one, okay, 1 minute here. So, okay. So here, if you want nth degree polynomial, please remember that you should not have an, that is nth term's coefficient, as 0. If it becomes 0, then it will not remain as the nth degree polynomial. Okay, that's it. So now we'll move on to the next part. So I hope everybody has noted down. I want really for you to note down this. This is a very important concept. Please remember this, because many of you were asking nth degree polynomial. So this is what is the definition of nth degree polynomial. Please note down this. Okay, I hope it's clear to you, students. So we'll move on to the next very important concept. So before we proceed to the actual concept, actually here we have to discuss polynomial. But before that, let us quickly recall whatever you have learned in your ninth standard. That is nothing but 0 of a polynomial. And also we have learned about remainder and a factor theorem. So we'll be discussing about that now in the next concept. That is 0 of a polynomial. Now what is this 0 of a polynomial? When it comes to the 0 of the polynomial, suppose you have a polynomial p of x. Just think that you have, and it can be anything. Just think that, yes, p of x is given to you. When you can say x equal to a, it means it is the value. Okay, we are taking x equal to some value. So if you are able to substitute this a in the place of x in the p of x and you get answer as 0, then we can say x equal to a is the solution of the given polynomial, or it can be even the 0, or it can be even, see, remember zeros have different names. It can be roots. Okay, it can be even the solution. It can answer, solution, answer, and zeros. Please remember this. Okay. Yes. So now we'll move on to the how to find the zeros here. These are very simple things which we have, which I'm discussing initially, because later on we will be moving on to the cubic part also. Yes, some of them have already solved this. So now how to solve this? This is very easy. A quadratic polynomial. You don't have to do anything much. You just take x common here. And if you take x common, then x remains here. And then you have 2, because the x is already outside here. When you multiply x into x is x square, x into minus 2x will give you minus 2 will give you minus 2x. So since, as I said, you want to find the zeros, so you have to put it equal to 0. So that will give you x equal to 0, and then x is equal to minus 2. So this is what we have. Some of you have already answered. Sorry, when you take this, it will give you plus 2, not minus 2. Please correct it. It is x equal to 0 and x equal to plus 2. This is how you solve it. Okay. This is a one question. So now if you want to check whether it is a 0, again you can check it. How do we check? You just take p of x is equal to, what is that p of x I have given? I have given it as x square minus 2x. You substitute x is equal to 0 in this, or maybe x equal to 0. It is very obvious answer. So let me take x is equal to 2. So if I take x is equal to 2, then this will be 4 minus 2 into 2 will be 4. So your answer is 0. So when I take x as 2, that gives me answer as 0. So that is why I can conclude x equal to 2 is the 0. Okay, clear? Yes. Next we'll move on to the quadratic polynomial here. Yes. So next here we'll move on to the next one, that is the quadratic polynomial here. Just for you to revise with that method, I'm just doing it again. So what is the first thing is, remember here x square is without any number, so that means it is coefficient is 1. So multiply the coefficient of x square with the constant term, you will get minus 6. That will be the product, and the sum is the middle number, which is here minus 1. So find two numbers, that is nothing but it is the factors. So factors here, 2 3s is possible, and even the 6 ones are, but since the sum is 1, it is only this is possible, so I can go for minus 3. The reason is I have 2 into 3 is minus 6, but I have minus here. That is why here minus goes for any one of this. But since the sum is minus 1, I have to take the greater number as minus. So that is why using these factors, I'll be splitting the middle term as x square minus 3x minus 2x minus 6. And as I said, you have to put it equal to 0. Now take first two terms, take x common, you will have x minus, and here you can also common, but minus is also common. Take that, and then you get x minus, here 1 minute, it is plus 2 here. I'm sorry, you can just take yes, plus 2 only common. You get x minus 3. Please remember that it is plus 2 and minus 3. So that is why here I take 2 common, then you remain with x minus 3. You can see that x minus 3 is common. Take x minus 3 common here, and then x plus 2 remains inside. I hope it is clear to you. So using this, you get x equal to 3 and 2 as the answer. Yes. So most of minus 2 as the answer. Most of you have already sent the answer. It's good, really good that I'm happy that you're solving it on your own. So it's a really good thing. Okay, so this is what we have. So now this is about the zeros of the polynomial. Now we have small simple problems based on these concepts, that is zero of a polynomial. So what is this? But before that, we have one more important point. That time we have what will be the zero roots. Won't you get a doubt? What will be the root of the zero polynomial? Correct. So zero polynomial, since all the coefficients of the zero polynomial are zero, we will be able to substitute any value for x, because whatever you substitute, the answer will finally become zero. So it doesn't make any difference. That is why we say every real number is a zero of the, or what here, don't get confused with these two zeros. Here 10 means it is, this says it is nothing but it is the root. Please don't get confused with the two zeros here. This is root. So every real number is the root of the zero polynomial. So please note this point, because here these may be small things, but when it comes to the problems and all MCQs, these can be asked always. So please see that you note down this. And then what about the constant? Now you know constant means it is just 2, where you can substitute x. You know that 2 can be written as 2 power x. So here you substitute x is equal to anything. Will it make any difference for us? It doesn't make any difference because it turns to be 1. So we can't have anything. So we'll say that non-zero constant polynomial has no zero, because it is like it's not possible. So we can't just put anything here. Okay, this term won't be there. It is because this becomes just 2 into 1. So x term won't exist. So there is no question of putting x is equal to any value. So we say that non-zero constant polynomial has no zero. Please note down these small things. It's very important. Okay, next we'll move on to the next concept, that is nothing but the remainder theorem. But before that, yeah, I want you to solve this. It's very simple problem. Okay, so somebody has asked me previous. So please remember here, for every real number is a 0 or the root of the zero polynomial, because there the coefficients are 0. X terms are not 0. Please remember that. X terms are not 0 here, only the coefficients are 0. So that is why whatever you substitute for x, it will be the root of the polynomial. That is why we say every real number is the root of the zero polynomial. Okay. And then one more important point is, since here in the case of non-zero constant polynomial, this x power 0 becomes 1. There is no x there to substitute anything. So that is why here we say that there is no 0 for the constant polynomial. Okay, and this is the next one. Here question is based on the 0 of the polynomial. They have given x minus 4 is a 0, and you are supposed to find out what is the value of this k. So what we do, as according to the what I have explained previously, you should remember p of a is 0. So what is that p of a? That is here minus 4. So we can say that p of minus 4 is equal to 0. This you have to remember, because it is 0 of the polynomial. So we get this. Now from where we will get this? So this we have to substitute x equal to minus p of x in this case. So that is why here we substitute x is equal to 4 in this. If I substitute, I will get it as 16, and then minus into minus will give you plus 4, Yes, most of you have answered it correctly. And then you have minus into plus will give you minus 2k. And then you have minus into plus minus 2 equal to 0. This is what we have. And then you can add this. This will give you 18. Okay. And then you can 18, because this will give you 20 minus 2 will give you 18, and then shift this to the RHS, you get it as 2k, and then that will give you k is equal to 18 by 2. So most of you are getting the answer as 9. It is correct. So this is what is the answer. So I hope it is very clear to you. So whenever they say p of find the value of k where minus 4 is the 0 of the polynomial, you have to remember this one step is very important. You miss this 0, there is no meaning for the entire expression. So please remember it to put that 0 in the answer. That's very important. You can note down this. Most of you have got the correct answer. Really good. Yes. Okay. Next one. Okay. I hope you have noted down those who did not get the answer. So next one is for you. And please note down the homework here, which has been given. This is from the textbook. I hope all of you have the soft copy of the textbook, polynomial chapter. It's a very short material what we have there, because we have already discussed about polynomials in ninth standard. It's again a revision since it comes under your syllabus. Okay. Yes. So now please find out what is the answer for this. Yes, textbook question number 23 it is. So now first finish this. This you have to do and you have to tell me the answer. I hope till now whatever I have explained it is clear. If you have any questions, students, you can raise your hand and you can ask whatever it is. Okay, already one person has answered. Yes, correct. Okay, let everybody answer, then only I'll let you know what is the answer. Okay. Okay, homeworks can be posted in Schoology. You can do that. You can click the image and post it. That's better, I think. Yes, most of you are correct. Good. Yes. I think you are able to calculate it. I told you P of minus 4 is 0. Then you have to substitute x is equal to minus 4. This is your homework, which can be done later after the class. Okay, so I hope you have done it. Most of you are correct, but some of you are still having the problem with this. Okay, so what is that is you just have to take first P of minus 4 is 0. And then when you take P of minus 4, you get this P of minus 4 from this entire thing. You have to substitute minus 4. So you get 16 here, because minus 4 the whole square, or minus 4 into minus 4 is plus 16. And then minus into minus plus 2 fours are 8. Okay, this is what you get. And then again here minus 7p as it is, and then you have here minus 3 equal to 0. This is what you have. And then when you add this, you get 24, and then subtract this, you get 21 altogether, and take 7p that side, you will get it as 7p here, and then you get p is equal to 20. I think most of you have got the answer as 3. Those who did not get it, please see that you do it once again. Okay, good. So now we'll move on to the next, that is the remainder theorem. Now what is this remainder theorem? I don't want you to by heart this as such. This is just a statement, students, but you just have to understand what is this concept is. It is nothing but it says, suppose you have a polynomial p of x, and you want to divide it by a linear polynomial x minus a, and you want to find out what is the remainder when you divide p of x by x minus a. In that case, what you do is you equate this x minus a equal to 0 with this and that will give you x equal to a. And substitute this x equal to a in p of x, and whatever answer you get at the end is called nothing but the remainder. Okay, this has to be remembered. This is what the remainder theorem states. So what you have to do is, suppose you want to find what is the remainder when p of x is divided by x minus a. You want to find that, then you equate the divisor to 0 and you get the values there, and that those values has to be substituted in p of a to get the remainder. Now we'll be learning both the ways to find the remainder. So what is that both the ways? One thing is, usually whenever they say p of x has to be divided by x minus a, the first thing what you do is long division, and then you have one more easiest method, that is the remainder theorem. Okay, so now, yes, p of x here, yes, it can be. See here, there is no restriction. When we give here definitions, most of the time we go with the simple linear polynomial only. But there is no restriction that regarding the quadratic or this maybe it can be a cubic also, depending on what is the degree of the p of x. Based on that, you may have here quadratic, biquadratic, or anything. It is possible. Okay, but most of the time we stick to the lower degree because the syllabus is very limited and we don't go for biquadratic and all that. That's the reason. Okay, yes, now we'll move on to how to find the remainder. So here we have the polynomial which is given, and we are supposed to find out what is the remainder when it is divided by x minus 1. Okay, and we will be discussing how to find the remainder when this given polynomial is divided by the quadratic or cubic polynomial later on. But now we'll stick on to the only the basic things, because we are just revising with certain things here. Okay, and yes, so some of them are already answering. But now what I want you to do is, I just don't want you to apply only the remainder theorem. I want you to practice your long division also. The reason is, towards the end we'll be using long division most of the time to find out the remaining roots of the given polynomial when they give you two or one root or something like that. In that case, it is very necessary. That is why let us practice today how to do long division in this case. So for that, first I want you to, I know most of you know it, but there is no harm if you practice because you become perfect. Okay, yes. So here is a long division process first, and in that case also, yes, you can do synthetic division as somebody has specified. Yes, that is also possible with that synthetic division. Actually, I had taught a few batches there. That time I had discussed about the synthetic division. Okay, yes. So we'll be discussing that about the synthetic division later on, because I need to teach it separately first, and then only I can come back to this. So that is why we'll be doing it later. Okay, yes. Synthetic division is a method of division which is very simple. Okay, yes. So towards the end, surely I'll be teaching you that, as well as how to draw the graph using the GeoGebra app. Okay, now let us move on to this. Okay, yes, I hope your queries are answered. Now, when you are using long division, I hope you are clear with this. So now here we have the biquadratic polynomial inside this one, and divisor is x minus 1. So what you do, you just have to find out x into what gives x power 4. That is x cube here. Okay, so x cube comes here. So here x power 4. Then minus 1 into x cube will give you minus x cube here. Okay, and then you just have to change the sign because you are subtracting. So this cancels. This will give you 2x cube. I hope it is clear to you. Those who have a problem with this long division and you're not able to understand how do you get this, it's very easy. Always take the first term here, that is dividend, and the first term of the cancel, you will get it as x cube. So this is how you find the first term of the quotient. Okay, this is how you do it. This is nothing but it is a simple application of loss of exponents. You have a to the power m divided by a to the power n. You can write it as a to the power m minus n, those who can't understand. That can be done. Okay, so then here we have again bring this 2x square down here. So here you have that. Then again x into what gives this? So those who can't, again you can follow this. Okay, it's just an optional part. X cancels, so you get it as 2x square. Okay, yes, so that 2x square comes here. Again it is plus. If it is negative you have to write it negative there. So x into 2x, the 2x square will give you 2x cube here, and then you have minus into plus minus 2x square. Again subtract, you get it as this becomes minus, this becomes plus, this entire thing cancels, you get 0 here, but we have remaining two terms. Bring it down here, you get it as x plus 1. Correct? So then x into what gives? That is very easy. Again, if you want to do this method, x by x will give you 1. So that will be the last part of the quotient, 1 here. So you get x into 1 is 1 here, minus 1 into this one is minus 1. Then change the sign. Here your answer will be 2. Remainder is 2. So most of the you have already answered that it is the this answer is 2. Yes, correct. This is using long division method. Now suppose if I want to use the remainder theorem, how it will be? That is nothing but you just have to take whatever they have given as p of x. So p of x is given as, please understand, this is long division method, and now what am I doing is the remainder theorem method. So suppose if they have given like this, plus x plus 1 here, what you have to do is, first thing is you have to take x minus 1, put it equal to 0, and then you get x is equal to 1. So substitute in this p of x, so you get it as p of 1 here, and then when you get it to p of 1, substitute 1 x is 1, you get it as 1 power 4 is 1, 1 power 3 is 1, minus 2 into 1 will give you 2, and then again x is 1, and last finally 1. So minus 2 and plus 2 gets cancelled. Your answer is 2. Now you can observe here that this one as well as this answer remains the same. Okay, remainder is 2. Okay, you will get the answer as 2. I hope everybody has understood this. Okay, yes, anybody has any doubt regarding this? No, right? Okay, now we'll move on to the next one. Okay, so I hope it is very clear to you. But why am I using this long division? The only thing is I just wanted you to revise with the long division. That's the only thing I've used for that reason I've used this long division. Otherwise, don't waste your time. When you know the remainder theorem, apply this method and find out the remainder. That is what you have to do. It saves a lot of time, and also you have to, yes, in case if they mention that you have to use a long division, you can use it. Okay, yes, I think there is some problem with the polynomial textbooks. Maybe it is in the drive, that is why, I don't know, you can just see it later. There is some problem with the network also today, so that is why you may not be able to do it simultaneously for time being. So you can just do it later. Okay, yes, and these things actually I have taken additional students, because the thing is, without teaching all this I can't proceed further. Your PDF, this one format, that material doesn't have all these remainder theorem, factor theorem and all that. Okay, so that's why you just okay, if there is any other problem, I'll just I'll inform the sir or a technical department, and I'll let them know that you are not able to open your textbook. Okay, yes, so that later on you can have access to your textbooks. But please note down whatever we are doing, because this is not there in your textbook. These are the additional things which I have put. The reason is this gives the base for your the next concepts what we are discussing. Okay, so next we'll move on to the next part. So now this is for you. I want you to divide this and tell me what is the remainder. And I don't want you to do it now. Please do it at home. I mean later on as a homework. Please note down this later on. Yes, some of them are already answering. Yes, maybe don't answer in general. Let everybody try it on. That is what I expect you to do, because without trying you'll not be able to do, because this is a small error. If you commit also, it becomes really difficult for you to correct it later on, because it is a polynomials. Okay, yes, I hope everybody has noted down this question. Yes, some of them are. Yes, you can yes, you can use anything, that's fine. Okay, yes, you can use either the remainder theorem, or you can even use the this one, what is that, long division, anything is fine, but I want you to do this. Are you able to do it? Okay, most of the answers have come back. Okay, yes. Okay, I'll be answering. Okay, you can. Okay, now I'll be doing the remainder theorem method, but I want you to do the long division later on after the class. That has to be done so that you will get used to it. Okay, so this one now here. Okay, what is your what is the answer here? So you will see equals you have x equal to 1, and I know that this is a p of x. So I have to substitute here p of 1, correct? So what is p of x? P of x is, this is p of x. So this has to be remembered. This is p of x here, and I have taken x is equal to 1. So when I do that, I get 3 minus 4, because 3 into 1 is 3, 4 into 1 is 4, and then here 3 again and minus 1. So here 3, if their answers are correct. I think most of you have sent. Okay. Most of the things are correct. Okay, yes. So I hope it is very clear to you. So this is about the remainder theorem. So answer is minus 5. Next, we'll move on to the next concept, that is nothing but the factor theorem. Now, what is this factor theorem? So it is actually factor theorem and remainder theorem. They are actually closely related to each other. Only when the remainder becomes 0, it is almost equal to the factor theorem. Now let us see what is the statement. So what is the statement? Suppose you have p of x and you have x minus a. You want to divide this, or okay. So if you equate it to 0 and you find it that x is a, and after substituting this x equal to a in p of x, and if you get p of a equal to 0, then in that case we will be able to identify whether x equal to a or x minus a is a factor. Suppose if p of a is equal to 0, then clearly we can say this is a factor. This has to be remembered. So please remember, this becomes a factor. X minus a becomes a factor when you substitute x equal to a in p of x, and it gives the p of a is equal to 0. Or in simple words, we can say a is the solution of p of x. That is what we have. I hope it is very clear to you regarding this. So then now when it comes to this factor theorem, it has two ways. That is, we can say it is an if and only if condition. Now what is the meaning of if and only if condition? Here if you observe, there are two conditions. You can read this. X minus a is a factor of p of x if p of a is equal to 0. And again it starts from the last. See, p of a is equal to 0 if x minus a is a factor. That means here both the ways you can state the theorem and it will be true. That is why such kind of conditions are called as if and only if conditions. Okay. So now what it says. Now I have told you, suppose if you have to divide by x p of x by x minus a, and you substitute x equal to a in p of x, and you get p of a is equal to 0, then clearly x minus a is a factor. Now suppose you know that p of a is equal to 0, then we know that x minus a is a factor. Okay, this is the first thing. X minus a is a factor. This is what we have here. So suppose instead of this, you have x minus a is a factor. You don't know that P of A is 0 or not, but you know that x minus A is a factor. I'm sorry, it's not working properly. Okay, so if x minus A is a factor, then clearly without doing any calculation, we can conclude that P of A is always 0. That is because of these two conditions. So please remember this, both the ways it is true. Okay, yes. So this is about the, okay. I think Rahul has some doubt. What is it, Rahul? Can you please speak? Then it will be more clear. I think I'm not able to get you. What is it?
Ma'am, in the previous question, while
Yes, previous question. 1 minute. Let me go to that previous. Yes, what happened?
while using long division method,
Okay.
uh, I guess the question should be minus 3x squared instead of minus 3x.
Oh, why we are not able to get the answer? Is it?
Using long division method, ma'am.
Yeah. Using long division. See here, I got the answer as 5. No, with x equal to minus 1. Same way, you will be able to do the long division also. Check this long division once again. If you have any doubt, I'll give you my email ID. Then you can mail it to me. Then I can identify the mistake and get back to you.
Sure, ma'am.
There is
Sure,
no
thank
square term. Okay. Your doubt is there is no square term, is it? If it is that is the case, there is one method which has been taught to you in long division. I don't think you remember. That's why I was making you to practice this. Whenever there is a problem with that kind, that is there is no square term and all, we replace it by 0 so that it will become easy for us to solve that. Okay, replace that square term by, that is you have to rewrite this as 3x power 4 minus 4x cube, and then there is no square term, correct? So you add this 0x square here minus 3x and then minus 1. Then you will be able to do it properly. If you have done it anything wrong, you use this and then you will be able to do it
you.
properly.
Yes,
Okay, will
yes,
you try
ma'am.
once
Thanks.
again? Okay, yes. Okay, I hope all the doubts are clear. Okay, yes. So now let us continue. Okay, so now let us continue with the next concept. Okay, so here is this. I was discussing about the factor theorem. Okay, so please remember this. Okay, yes. So next, here is the question based on factor theorem. Now, what it says, find the value of k if x minus 1 is a factor of the given polynomial. So, as soon as they give you the question like this, the first thing what you have to do is take the given polynomial as p of x minus 1 is a factor. So you take x minus 1 equal to 0 and then you get it x equal to 1. You have this and then you can come back to this, substitute p of 1 here because x is 1 here, and then 4 into 1 is 4, and then 3 into 1 is 3, and then 4 into 1 again is 4, and then you have k here. And remember, since x minus 1 is a factor, p of 1 is always 0. From where you get this? Because of this statement. You get this. P of minus 1 is 0. So substitute here, P of 1 is 0. So substitute here, plus 4 and minus 4 cancels. Take it this side because it is 0. Here minus 3 you get 3 plus k here. So answer is, as most of you have answered, it is the minus 3. Correct. Good. So I hope you have understood clearly. Okay. So what is that we have question here? Find the value of k if x minus 1 is a factor. Remember, whenever x minus 1 is a factor, it is nothing but it is telling us p of minus 1 is 0. Okay. Yes. So now this is about the question. Please note down these small things. Okay. Next we'll move on to the next problem. Okay. Okay, next. This is the next question. Now you have to tell me whether x plus 2 is a factor. How you can prove? First thing is put x equal to 2, x plus 2 is equal to 0, and then substitute that value. And if you get a 0 by using factor theorem, we can conclude that x plus 2 is a factor. So complete this and then let me know what is your answer, whether it is a factor or not. I want yes or no answer. Okay, yes. One person has already answered. What about others? Yes. One more. Ketan, Nicole. Pratyusha, I think. Pratyusha, and then Shraddha, Sai, Pratiksha, yes. Satvika, Shashank, okay. Navya, Nidhi, Sushant, Sachin, yes. So almost most of you have answered. Answer is yes. So according to me, the answer is yes. Why? Because when you take this equal to 0, you get answer as minus 2. X equal to minus 2. Substitute that, you get it as minus 8. Then 3 into minus 2 into minus 2. That will give you 3 into plus 4. So you get it as 2, 12. Okay, here. And then you have 5 into minus 2, 10. And then you have plus 6. What is your answer? Here, minus terms you have to add, you get it as minus 18. Add plus terms, you get 18. So cancels. What is your answer? You had substituted P of x equal to minus 2. And now you finally ended up with P of minus 2 is equal to 0. Then it will be nothing but the factor. So your answer is nothing but it is yes. So we'll move on to the next one. Yes. So most of you have answered correctly, and those who have not, please check this one. Okay. Yes. So I'll be checking my email. If you have any doubt, you can always mail it to in that. Okay. Yes. So next we'll move on to the next, that is the relationship between the coefficients and the zeros. But before that, let me quickly recall whatever we have discussed. That is nothing but what and all we have discussed in today's class. We have discussed about the algebraic expressions, we have discussed about their types, and we have discussed what are the coefficients, what are the constants, and all that, and the classification of algebraic expression based on based on the nothing but the number of terms. That is, we have monomial, binomial, trinomial, all that. And then we had the classification based on the degree. We had the linear polynomial, we had quadratic, we had cubic, biquadratic, all that. And after that, we had discussed what is the solution of the linear equation, what is the solution, how to find the solution of linear equation. You are very much familiar with that. We'll be discussing once again. And then we have the standard forms. We have discussed how to factorize the quadratic polynomial, all that. So next, now we'll move on to the next type. And also we have discussed about the factor theorem. Please don't forget all this, because later on we will you may come across different kinds of questions. Okay. So now let us move on to how to find, or what is the relationship between the zeros and the coefficient of the polynomial. So first we'll start with the linear polynomial. Let us take a very simple concept. Okay. Yes. So what? Let us take a very simple equation. I'll take 2x plus 6. Now you find out what is the zero. How do you find out the zero? Is it in standard form? Yes, it is in the standard form. Ax plus b. Using that, I can identify that A is 2 and then B is 6. Correct? Yes. Okay. Some of them have already answered. X is nothing but, if I want to solve, then first I have to shift 6 this side. So it becomes minus 6 here, and then here I have to shift this 2 to the RHS. So it becomes since it is a multiplication, it becomes division. Okay, this is what you get. Yes, most of you have answered it correctly. Now, how if I denote that this solution, whatever I got as alpha, alpha is one of the symbols which we be using. You know the symbols and all that, so that is there. And we have the block letters as well as the small letters for this alpha, beta, gamma. We have like that, or maybe even the pi, or maybe summation. All those things are there. Different symbols we use here. Most probably we'll be using alpha, beta, and gamma as the symbols. So now this is the alpha symbol. So suppose if I denote then relationship between this alpha equal to -3 and all this coefficient is, it is based on this step. You can clearly see that I found alpha, but I know that this is B. B is 6. So it is B, but I don't have this minus. So I'll put it here. And then I have this 2, which is A. So in general, if you want to find a relationship between, okay, if you want to find the relationship between the zeros and the coefficient in the case of linear polynomial, then it is nothing but alpha is equal to the theoretical way of writing this. That is nothing but they say alpha is equal to minus. Now you know that B is a it's a constant term. So they write minus constant term divided by, a is a coefficient of x, so they write it as coefficient of x. That is also correct. Okay, so now what you can do is you can write this example finding. Okay, yes, I'll be discussing about that. Okay, I'll be coming back to that linear equation in two variables. Okay, I'll be coming back to that. Now for timing, please copy this. Okay, please copy the examples, and also please copy this, and I'll be giving you in the next slide I'll be giving you theory for this. That is how to write in terms of theoretical way of writing that solution. Okay, yes. So now somebody asked me, what happens if the linear polynomial is in two variables? When it comes to the linear polynomial in two variables, I hope you remember you had last year in your classes, that is linear equation in two variable has infinitely many solutions, correct? Here, when it comes to the linear polynomial in one variable, it has one exact solution. So it becomes very easy for us to define the relationship between the solution and the coefficient. But when it comes to the concept of linear equation in two variables, since it has infinitely many solutions, it cannot define the relationship so easily. Still, if you want to move further, maybe we can take a linear equation in two variables and we can write them as in a matrix form. Actually, you will come to know that is a cross multiplication method and all we use, where we use the matrix, or what you call it as a determinants and all that we do. But then we have to solve the linear equation in two variables. That is again a different concept. It is a we call it a system of linear equation, or we call them as simultaneous equations. Yes, Kramer's rule, all that can be used. We have different concepts for that. We have three, even when it comes to linear equation, three variables also, we go for the matrix. Okay, yes, as you said, it comes mostly in that finding the inverse of a given matrix and all that, there we will be using, or maybe find the value of x, y, z, then in that case we will be using. It is again an entirely different concept. Okay, yes. So I hope your doubt is cleared. So since if you take just a single equation, it becomes really difficult for us to identify this relationship. The reason is we have infinitely many solutions. We don't have one single solution as such. Okay, so that is what we have, I think. So this is enough for today, because tomorrow again if I start with this one quadratic equation, it will take some time. So please note down this. This is what I wanted to give you. 0 of a linear polynomial ax plus b is always equal to the minus constant term by coefficient of, I'm sorry, this is not b, it is coefficient of x. Okay, that is equal to minus b by a. Please write it properly. Okay, yes. So that is what we have. So I hope it is very clear to you. So kindly remember the homework I have given you. Some of them have already answered that question to me. I'm happy for that. That they know already, they remember that. Others, please recall what is that quadratic equation in two variables, which you have already learned last year. So that is what I want you to find out and come back. And I think one homework I have given you, question number 23 from the this one. Okay, you do. Yes, it is better if you maintain a separate notebook, and I think you better upload it to the Schoology so that I can just check. You can click the image and scan and just upload it. That is also fine. Okay, yes. And I want you to recall all the concepts what we have discussed today in today's class, so that I can just ask you a few questions. Maybe we can have a small quiz tomorrow, as we start with the classes. Okay, yes. So that's all we can do. I hope. Okay, I'll talk to sir regarding that problem with the unable to access the notes. I'll be doing it. Okay. Yes. So I hope you have any doubts, students. If you have any doubts, you can ask me. Okay. Yes. Okay. So my email ID is either you can mail it to the mm, this one, that is 1 minute. You can mail it to this ID, students. That is Shilpa M at tlc.edu.in. Okay, you can do that. You can mail it to Shilpa M, that is sh.edu.in. You can just mail it to that and I'll be checking it. If you have any doubts, you can do that. I hope it is very clear to you. Okay, yes. So thank you, students. That's all for today. We'll meet tomorrow. Hope can you repeat the email ID? It is sh. Edu.in. Education. Yes. I hope it is clear. Yes. Thank you. Yes. Thank you. That's it. Okay. This standard form and the general form, or what you can call it. Okay. You just have to go back to your this one previous year textbooks and search and tell me what is that famous concept which you learn. Okay. Yes, that's it. And then I think one more long division I have asked you to solve. These are the homework questions. That's it. Okay. Yes. Thank you.